या हो गया वो। हाँ, लेकिन वो अभी से ही रिकॉर्डिंग चालू कर दिया है, या अभी से ही रिकॉर्डिंग चालू कर दिया है, तो अभी नहीं करना है। हाँ हाँ हाँ, नहीं नहीं, हाँ
Sir, I can stop this if you want.
इसको
Anburajan sir is not able to join. Can anybody help him?
ओके, या ठीक है।
Yes, ma'am. Who is not able to join?
Dr. Anburajan.
Sorry, I didn't get that
He cannot
name.
join in both the links. He's got 2 links. He's not able to join.
Sorry, I didn't get the name, ma'am.
Dr. Anburajan.
Okay.
Anburajan. Anburajan.
He will be ready in exactly 1.5 minutes.
Ah, okay.
बटन चालू कर जमा सोडा कर इकडे आता ते ठेवून लागला लागला
I can see myself. Thank you.
Yes, yes, sir. Now you're fine.
Good morning, join now, sir. Yeah. No, do one thing.
Is the light okay now?
Station, that tiny URL from the
So approximately how much time do we have at hand to start? Dr. Yashoda, you're on mute.
Unmute.
Yeah. I think inauguration is around about 10 o'clock or something, no?
No, he wants to know how long he can speak, right, sir?
No. Speak no. I was just trying to get a few things in order because I'm not starting anyway. Dr. Bondwe will start. Because, initially,
Dr. Bondwe will start.
Dr. Bondwe, you muted yourself.
No, तो अभी secretary के लिए wait कर रहे हैं.
Difficulty in joining. I told the host to organize his link. Once he joins, we'll start.
Okay, so we have like a couple of minutes here, right?
Okay.
We can wait for another 5 minutes.
Yes, sir. Wait till that.
Even Dr. Anbarsu is not able to join.
After this rush of changing places and this and that.
There is some problem because when I was joining also, it said that you have already joined in another device.
The same thing.
I haven't done it.
Same thing happened to me.
Yeah.
to me, but
Good morning, Dr. Lele.
Good morning, sir. Lele, sir.
good
Yeah,
morning.
morning.
Good morning,
Morning,
sir.
sir.
Namaste.
Sir is on mute, I think.
No.
हे उजवीकडे जो DNA आहे ना, तिथे आपला तो वेबसाईट पाहिजे.
Yeah. Dr. Anbarsu has joined.
Good morning, sir. Good morning, sir.
Morning.
I got sir. Avinash, sir. Good morning, sir. Rekha.
Morning.
Good morning. Good morning. Good morning, madam.
Good morning, sir. I was just trying to answer your call and you have already joined.
Yeah. Rekha, I didn't get it. That's why I just called you.
Yeah. Yes. Yeah, okay, sir.
Good morning, Dr. Jayesh Lile sir. Namaste.
Good morning, sir. Jaisley, sir. Good morning, sir.
He's not unmuting himself. Lele, sir, we can't hear him.
No, I am on mute.
Sir.
Sir, good morning, sir. Lele, sir. Good morning, sir. Morning. Genomics பத்தி என்ன பேச டாபிக் எனக்கு பாரு என்ன பாரு ஏதாவது 2-3 பாயிண்ட் அழுத்து
Yeah. Just call again, Dr. Anburajan. There is some problem. Sir, what happened? Huh? Join first. Even Dr. Lele has come. Dr. Rekha?
Yes, sir.
Yeah. Do you have the IMA
Yes,
prayer
sir, I have.
salutation? Okay. If
I have IMA prayer and physician's prayer. Anybody else coming for the salutation?
no, you can do both. If Anburajan join.
Yeah.
We'll wait for another 2 minutes. He joins. Otherwise, Dr. Anbarsu, you begin.
Yeah,
As
yes,
per
sir.
It's already 10:15. Okay, Anbarasu sir.
Yes, sir.
Huh?
Yes, sir.
Yeah. Begin after your welcome.
Yes, sir.
Dr. Rekha will give here and salutation, then pass it to me. After
Yes, sir.
me, Dr. Lele will be.
Good morning, sir.
Again.
Good morning, our beloved Dean Avinash ji and our Secretary General Lele ji, Rekha, and Yasoda, and Anburajan, and all the people who are attending today, and who are the people who are going to teach us about the genomics, because this is a fantastic topic which was coined in 1986 by Roderick. So this is a very good point, which will be helpful in our future, in all our studies, which will be more useful for the private practitioners. Our Dean has selected such a good topic, and we must really thank him for taking up all the efforts and bringing all the faculties to see to that we are learning within these 4 hours what is possible maximum. So without wasting my time, I once again thank all the faculties who is going to give us knowledge, and our Secretary General and our Dean and all of you. On behalf of CGP, I thank you, and I welcome you all for this wonderful session. Thank you very much, sir.
Thank you so much for your kind welcome, sir.
So we begin with the prayer. I may prayer. May everybody be happy. May everybody be healthy. May everybody be free from pain. May everybody be free from sorrow. May we be the healing cure beyond every greed and lure. Physician's prayer. Dear Lord, thou great physician, I kneel before thee. Since every good and perfect gift must come from thee, I pray, give skill to my hand, clear vision to my mind, kindness and sympathy to my heart. Give me singleness of purpose, strength to lift at least a part of the burden of my suffering fellow men, and a true realization of the rare privilege that is mine. Take from my heart all guile and worldliness, that with the simple faith of a child, I rely on thee. Flag salutation. We, the members of Indian Medical Association, stand here to salute our national flag. Its honor and glory shall be our light and strength, and its course shall be our course. We pledge our allegiance to it, and realizing our responsibilities as the accredited members of this national organization, we swear we will dedicate everything in our power to see it fly high in the Committee of Nations. Jai Hind, long live IMA. Thank you, and over to Avinash, sir.
Thank you. Honorary Secretary General, Dr. Jayesh Lele, sir, all the dignitaries of IMA CGP Headquarters, Dr. Anbarasu, the Secretary, Dr. Rekha, the Joint Secretary, Dr. Anburajan will be joining in sometime, and of course today's speakers, faculties, and our contact person, the main person of this today's CME, Dr. Atul Gadagkar. Thank you very much. On behalf of IMA CGP, I welcome all the delegates, and this is a very important CME which we have been conducting on a novel subject, in which many of us do not know, but this genomics has come into picture in last few months, especially during the Corona period, and we are all we want to know much more things, because we know genetics, we know that the genome, what is genome, the material, the study of genome is genomics. That much we know. We also know that it will be very effective in not only the treating but the diagnosing the diseases. And in coming days, it will be really a thing to work upon. We have been rather listening to many news that the genomics will be useful in treating some very difficult diseases, even in cancers, Huntington's disease, and so on. So we are very much curious. IMA CGP, this year we have been conducting some CMEs and some conferences on the very innovative subjects. This is one of them. Last month, we conducted a very, very important CME on psychiatry. And in coming days, with the help of our HSG, we will be conducting some courses and some fellowship courses in this. I appeal all the IMA CGP members all over India to join and to look forward for very important topics, which will definitely help to keep up your practice and to reach to better heights. So with this, I again welcome everybody and pass request Dr. Jayesh Lele sir to give his blessings. Thank you.
Yeah, thank you, Dr. Avinash Bondwe, Dean CGP. Today's our guest speaker and the faculty, as well as our own colleagues from the CGP headquarters, Dr. Anbarsu, Dr. Rekha, Dr. Yashoda. On behalf of IMA Headquarters, I welcome you all for this very interesting, innovative, and a new topic for the especially primary care physicians. Our national president is attending a conference of WMA, that is World Medical Association, and he is in Paris, so he is not able to join. I had a talk with him yesterday, but of course, any CME related activities, IMA is always in the forefront. And I'm sure under the leadership of Dr. Bondwe, Dean, a lot of new activities will be taken up. He will follow normal protocol for the CME, of course, but for the courses, we are checking up with our colleagues, the seniors, how to form the courses and have a more added value to it. Just conducting course for the namesake of certification, we will not follow. We'll do it in a proper, in a methodized manner. We have especially from last 2 years established an accreditation board and a council which directs us how to conduct the course, and that is how all courses will be followed. Regarding today's topic, especially talking of genomics, as Dr. Bondwe has already elaborated, it is going to be the future, and to understand the development into the genes and the genome, basically. Every gene represents the entire body of the particular person. And especially the chronic diseases, asthmas, diabetes, blood pressures, and cancer, of course. So many diseases are definitely related to that. At this moment of time, the entire treatment on the oncology, especially chemotherapy, and the future will depend on the genes, how they behave, and how which tracking and which treatment can cause to help that elongate the disease. I mean, reduce the disease and elongate the life for the, especially in the case of malignancy, diabetes, and blood pressure. Especially the juvenile diabetics, we have a long way to go because we have a great population increasing in terms of the juvenile diabetes. Our younger people are day by day dependent on the insulin. A lot of complications they develop, and in the difficult many times to monitor them, and costing involved is very high. So today's subject, especially for the family care physicians, is very important and is going to enlighten us about the developments of this genome, further issues, further how they will be useful for our practice. So I really thank the entire CGP team led by Dr. Bondwe and faculty also for helping us to have this very interesting subject. Thank you so much. Over to you, Dr. Bondwe, for further proceedings. Thank you.
Yeah. Dr. Anbarsu,
Yes, sir.
Dr. Rekha, ma'am, please give vote of thanks to for this inaugural session. After that, we'll be handing it over to Genescope.
Yes, sir. This is a good subject, sir, what you have selected. As Lela sir and you told, this will be a very good topic for our general practitioners, especially for the primary care physicians, how to manage. And this will give you a long way for managing the, like Lele sir said and you said, maybe for the juvenile diabetic and juvenile cancer and all these things, it may be a very good subject. So which will be good for the even for the breast cancer and cervical cancer and all these things. This study will be very much useful. Since you have selected the best faculties for us, for all the general practitioners to hear. So today we are going to learn the maximum thing what is possible today, which will be useful for our future practice. Thank you very much for all these faculties. And especially I thank our Secretary General Sir and Dean and all our members for attending this and conducting this program. Thank you very much. On behalf of CGP, I thank every one of you for attending this program. Thank you very much, sir.
Yeah. With this, we hand it over this session to Genescope, to Dr. Atul Gadakar. So please carry on, sir. Thank you.
Yeah, thank you so much. At the outset, although the vote of thanks is at the end, I really appreciate, and I would like to thank you all, Dr. Avinash Bondwe, to helping us, promote and propagate this new age science, as Dr. Jayesh Lele and Dr. Anbarsu just mentioned. Yes, it's new age and future medicine. It is something where medicine is also moving towards in terms of precision and personalization. Because it's new and it's a new topic, we would start off by explaining what's genes, DNAs, etc. But just give me a minute. This is my first webinar. I've done live seminars earlier. So I'll request my partner to just help me set up the presentation so that I will go as per the slides and talk about genes and DNA, what is chromosomes, etc. first. And my colleagues will also be talking specifically about specialized subjects like nutrigenomics and pharmacogenomics later. Thank you, Vishwajit. Yeah. Hope you can see my screen.
Yes, sir.
Yes, sir.
Yeah.
Yes, it's absolutely clear.
Yeah.
Go on, sir.
Yeah, just give me half a minute. So I will just click next, right? So genomics, the future of healthcare, as we just discussed, we will try and give some insights into the field of genomics. College of General Physicians, which is typically academics. And at the outset, I would also like to say, although the family physician business is or the faculty is dwindled considerably, currently general physicians are the connect between the general population and the medicine, where general physicians actually guide all the patients at an early stage. When they face difficulties, they help them refer patients to specific hospitals and doctors and the kind of treatments, etc. So general physicians, if they are aware of the genomic world, they can probably incorporate genomics into their regular or daily practice, like pathology or radiology has eventually evolved into regular practice. So would genomics very soon. It is already taking shape in a big way in America and England, but we always follow America and England. Why not take the lead and take a few steps beyond what they are doing? Because now we are all connected, we are all aware, we are all globally aware of things. So we should try as a collectively, as a medical faculty pan-nationally, try and progress genomics. Like we had the IT revolution, we should have a genomic revolution here in this country, and probably be ahead in terms of understanding what genetics is. So I'll start the slides. I hope I'm doing the right thing. It's not moving. Okay. Stop sharing. Sorry, give us just a minute, please. So I would basically, I would just go through the agenda, what we are doing today, which includes introduction to speakers, all the three of us who are basically presenting today. Then I would also give a brief mention on the genome-wide analysis, the GWAS, which is the central global body which keeps on researching in genomics, specifically SNPs, the single nucleotide polymorphisms which are associated with disease. So it is like a reference library, or it is a catalog which everybody has to, like we had Gray's Anatomy. So the GWAS is the basically holy Bible or the Grail for genomics, which keeps on getting upgraded. There is a latest upgrade likely maybe very soon. So if we are all ready and then we take on the newer, the latest catalog, we will be able to incorporate and probably deliver a better healthcare solution, a precise and personalized solution to all our patients. So we as Genescope.ai, I will do a brief introduction on that. Then what is DNA, genes, chromosomes? You can see the agenda. So instead of going through, reading through the entire agenda, as we go along, you'll probably figure it out. So I'll just move on to the next slide. Okay. So today's speakers, myself, Dr. Atul Gadadkar. I'd do a brief introduction. I have practiced surgery after my MBBS. I had a mishap. I had to discontinue my MS surgical posting. But my father was a surgeon. We had a multi-surgical specialty in Satara. So I practiced in Pune, Satara, Mumbai, a few hospitals here and there. I practiced surgery for the early 10, 12 years of life. And before which I thought there was a need to evolve myself a little better. So I went to the UK. I worked with the NHS. I was there for 12 years odd, where I came across all the new age medicine, which included genetics, which caught my eye, and I knew genetics is progressing considerably. So instead of continuing on surgery, now I have decided, now as in since 2013, so it's been a long journey since 2013 that I've been involved in genetics. Then we have with us also Dr. Amol Raut, who's a PhD microbiologist in molecular biology. He's been involved in genetics again, let's say approximately 12 years plus. He's been quite a pioneer in nutrigenomics and pioneer in nutrigenomics. So if we consider the number of nutrigenomics tests that ever took place, we as a group collectively, we have done 20,000 plus tests pan-nationally. So we're quite a leader in the field of nutrigenomics and of course clinical genomics. There are other players, and there's a lot going on in genetics in the country at this point in time. And we have also with us Dr. Kedar Joshi, who's a MD pharmacologist. Pharmacogenomics is a very important subject in genomics. He's involved with resilient cosmeceuticals, and he would give us a brief on pharmacogenomics at the end. Okay, so to begin, I would just start off with a brief on what connects us as physicians or doctors to patients, like the non-communicable diseases, which I will discuss a little in depth later, as Dr. Lele and Anbars also mentioned. Cancers, obesity, diabetes. We are practically the capitals of CVD and osteoarthritis. The number of the incidence for all these non-communicable diseases on the big rise in this country. In fact, I remember reading somewhere, that's why I could not find the real stats, but it costs our country in trillions of dollars. We as doctors, as we did in our prayer, that we also have an allegiance to the country. So as health soldiers, if we physicians come together, incorporate genomics in our practice, and because this is more of a preventive, proactive approach and a very personalized approach, rather than as standard medicine, we do a little generalized, or it's one cure for all. It is one cure for an individual. So I have taken an example of obesity, for example, to begin with, which it is basically a disorder which is calories consumed versus the amount of calories that we burn in a day. We have a considerable sedentary lifestyle now. It was when our genome was made, maybe some a few thousand years ago, humans also had a very active life, and the genome has not evolved considerably from that stage until now. Ours is a very sedentary lifestyle, so our calories burnt are a little less, and the consumption has not gone up. In fact, it has gone up with all the mithais and everything that we keep on having, which has led to a typical, outset of metabolic syndrome, I can say, which is also an obesity-driven or influenced state of health, which includes diabetes, heart disease, stroke, cancers, etc. Where we can say what genomists or geneticists realized was people living in similar environments, they become obese. So you are experiencing to the same thing. However, some people stay thin, some people become fat. Now, why with the same environmental influence, we have two different type of settings? That is basically because individually they have different genetics. So a lot of comparison studies were done between obese and non-obese people in terms of the dietary fuels they stay, the type of food they have, or there were studies done while people were hungry and with food intake, and a lot of knowledge about obesity and the genes related to obesity was found. Similar studies are carried out in GWAS, the genome-wide analysis about other diseases. It is progressive, but a considerable inroad has been made into genetics so far, which we'll see in the future slides. So I will start out by talking about GWAS because, as I said, it's the Holy Grail or the Bible. It is good to know about. GWAS. It is a genome-wide association study which is done by some global institutes, which the information is used to detect, treat, and prevent certain diseases. So it enables the reference library, because we need to have some reference which is like a normal human being. Although as geneticist, I also believe that if you are born, there is always a risk. The minute you're born, there's a risk for a lot of things. If you're not born, there's no risk. I mean, you as an existence, just because you're born, you're exposed to a lot of things, a lot of environmental issues, your genome issues that happen. So you're exposed to this. So we have to analyze that. Typically is what genetics does. I'm a little unsure. Can you all hear me clearly? I can't see myself in this presentation. Sorry. Hello?
Yes, sir, we can hear. Your screen is also clear.
I'm audible and the screen's clear. Yeah.
Yes, yes.
I was just worried while I was talking just now. So
no, we can hear you.
Let me get back to the presentation. Thank you, ma'am. So with the completion of the Human Genome Project in 2003 and the International HapMap project in 2005, researchers now have a set of research tools that makes it possible to find genetic contributions to common diseases. Now, since every person is different, this is a very important aspect, because every individual will have a different way of approach, a different way of dealing with this particular issues, where genomics really comes in very handy. Because genomics is also such a huge data-based or information-based activity, that as humans, it would have been very time-consuming and very difficult to take things ahead. So a lot of computerization, digitization, using a lot of algorithms, etc., were used. So which we will see the kind of data that we are dealing with, or the information that we are dealing with, we will see as in the next slide. So with these computerized databases that were created for GWAS, the human genome sequence was made, and it has been used to basically use genetics in clinical practice or non-clinical practice in lifestyle management to improve on health for individuals. So the next latest revised publication will be released soon. So it would be apt for us to know about this and go ahead. So I would also request IMA that, although genomics is a massive topic, I mean, this 2-hour presentation is definitely not enough to, send the message across. We will definitely go around and talk in general about genomics, but we would appreciate if you are given this opportunity a couple of times more, so that we can probably discuss certain diseases or certain issues, common issues that relate to genomics in a slightly greater detail as we go on. So, which will so that we as doctors can understand, apply these principles in daily practice and gear up for the future in medicine. Oh, I'm stuck again. Sorry. Next slide, please. So we as a group, we came together and we created Genescope.ai, which is a flagship product of Genescope Health Tech Private Limited. That's our setup to basically collect and pass on the information to doctors about the advances in genomic science. So the name clearly says genes is testing to understand individual genomic profile. We need to know every individual's DNA or genes, which is the basic component of the DNA, and the scope that it creates, which is providing personalized and customized services and solutions to every individual. Now, this is, as I mentioned, is possible with a lot of, we definitely need a lot of computer or digital help. That's why the .ai, the .ai extension like .coms or .gov extension is basically artificial intelligence, which is digital platform for continuous monitoring and engagement of the person. I did mention our speakers, of which Dr. Atul Gadakar, that's myself, and Dr. Amol Rao, who's a geneticist, I did mention about. But we also have a like-minded data scientist, Mr. Manoj Karde, who's had more than 12 years of experience in data science and digital information, digital systems. And Mr. Vishwajit Jathar, who's a precision pharmacist. He also has a lot of IT experience. He's worked in Europe, America, various parts of India, different pharmaceutical companies. So we are quite aware of the cutting edge scenario as a group, as a team, which helps us analyze and, basically promote genomics at a different level. So let me, as I mentioned, let us start off with understanding what is a DNA, what is chromosomes, what is basically SNPs, single nucleotide polymorphisms, etc. So I've just included this slide where there's a ladder, which is a twisted ladder. That's how a DNA looks like. Now, this is nuclear material which is present in the nucleus of a cell. Every cell has a nucleus except red blood corpuscles. Besides RBCs, all other cells in your body have nucleus, and part of that nucleus, the headquarters, is based the think tank, which is the DNA, which is the operating system of our body. Because the DNA, once you're born and until you die, it does not change. That's why we've called it as DNA. We refer to it as the does not alter. What changes is the expression due to environmental effects, which we'll discuss later on. So DNA, I mean, it's deoxyribonucleic acid vis-a-vis RNA, which is a single strand, nuclear material. So this DNA is basically made. It's like a cotton ball or a, like the woolen, when we knit sweaters, we have this woolen ball. The nuclear material is like a cotton ball based in a nucleus. So when we say chromosomes, the way we see it, the pairs and this and that, actually, when it comes to reality, it is not found in pairs. It does not, it's a graphical representation of the DNA. So that DNA is broken into various parts with similar parts. And it is the chromosomes, this is a graphical representation of the DNA. So a DNA per se is made of a lot of these nucleotides, like we know about the ATCGs, A pairs with T, C pairs with G. So this is like an allele. So one side is from the mother, one side is from the father. So both these characteristics come together and form a characteristics for the new child or the new being. So we typically have 46 chromosomes, or let's say 23 pairs, of which one is the sex. I will not go into too much detail because we are quite aware of it, but it's a huge amount of information that is collected from father and mother. So we have like 3 billion subunits, the bases as we call it, the nucleotide bases, 3 billion of those. And of the entire DNA, if you consider only 2% of this DNA, which is like the 25,000 genes which code for proteins. Now, again, these are the known 25,000 genes that code for proteins. That does not mean this number is going to stay constant. Maybe there might be a research which will just prove this wrong, but at this point in time, it is still a huge amount of data, which is good enough, because we've had some fantastic results with our cases in terms of lifestyle management or creating pharmacogenomic or oncogenomic solutions. So this 25,000 genes data is quite a huge data for doctors at this point in time, and it has become quite formally accepted in clinical practice now. So even with this 2% of the information, or 2% of the DNA which codes for genes, which is like 25,000 genes, there's enough information available for us to impart it as a part of clinical practice. So just to talk about the amount of data or the amount of information or the amount of complexity or the intricateness of the DNA, you can see the DNA in the middle, of which we can say, I just mentioned there are 3 billion base pairs, out of which only a difference between two humans is maybe less than 0.1%. But that 0.1% of the 3 billion databases is still 3 million differences in our DNA. So that is, in terms of the differences at a numerical value, it is massive. However, it is only 0.1% or 2% of the DNA. So it's quite a small amount compared to the information. So when we talk about the information on the DNA, how much information it exists. So if you think about one cell, that one cell has one nucleus and it has got microscopically, it is, I call it the God particle, because at that level, at a microscopic level, there's 2 meters or 6 feet of DNA coiled in that one cell. Now, if you look at humans, we are maybe what, 100 trillion cells or something like that. So if you multiply that by 6 feet, which is like 600 trillion feet of information. So if we lay down this DNA one after the other, we can go to the sun and back around 70 times. There is so much information. That is why I call it the God particle, because this is something beyond human comprehension. It is humongous. And if we were to read one letter at a time per second, at 24 hours a day, it would take about 100 years to recite the entire human genome. That is exactly why we need the supercomputers. Because yes, it's possible, because many people can do it together, collect the information, come up with solutions. But nowadays, with the advanced technology, it has made life very easy with the computers and the digital outlay that we have. Now talking about DNA per se, we also call it the universal life code, because every living being, may it be a virus like the COVID one, or may it be some bacteria like the bad nasty ones like tuberculosis, or the good bacteria like the lactobacillus, etc., to bees, plants, all types of plants, humans, all animals, we all share a common connect through a DNA. Everybody has a DNA. Although, even if we consider the closest of animals, which is like a chimpanzee, we are still 96% the same DNA as a chimpanzee. Is that 4% which makes us very different? Now, sequencing all this, when you talk about the information that we are aware of, that we know of, it is nearly 200 GB of data, which is the size of an average computer. So there are big computers now, 1 TB, or there are certain other computers which are lower, but our genome is 200 GB of data that an individual has. When we talk about the whole genome, which is sequenced, it is so much of information that is understood and analyzed before certain outcomes are made. So all in all, it is huge. It is extremely massive, but the technology has helped us make it very easy at our fingertips. Now, coming to we as doctors, we have to know the future of use of genomics. I mean, how do we incorporate that? So on our right, we can see that we have a conventional medicine, which is protocol-based medicine or volume-based healthcare, or one-size-fits-all approach. However, so like if you have a headache, we just prescribe, let's say, paracetamol. So when we do that, the dose is already fixed. Oh, yes, of course, it is very evidence-based, but not necessarily everybody reacts or, basically responds to a treatment in a similar way, because every person is different. That is why one size fits all is, although it is good to treat a person at a one size fits all approach, with genomics, it has given us the advantage of every person is different. So every person, there are like 6 billion different varieties. If you consider the global population of 6 billion, all 6 billion people are different. So we have to approach everybody individually. Although our common clinical practice, one size fits all, is essential in history taking, knowing things based on whatever information we've collected. But in terms of diagnosis or treatment, the one size fits all is not 100% what do you call as approach towards taking care of person's health. So genomics comes into play over there. So if you can see the circle, it says better diagnosis, better prognosis, fewer adverse events, optimizing treatment selection, as in designing. So pharmacogenomics, for example, we talk about regimes. So we are talking about drugs and regimes very specifically meant for that particular person. It is similar to the sensitivities that we do with infection and prescribe antibiotics. There are certain resistant bacteria. There are certain bacteria which the antibiotic is suitable. So there's a personalization over there in terms of treating that particular bacterial infection or a certain infection or certain other case. Warfarin doses are being very personalized because everybody reacts a little differently to warfarin in a different manner. So basically optimizing treatment, there is improved access to therapies, better disease monitoring, effective clinical trial participation, because this is still, in spite of everything, as I said, this is a very progressive science. So the more information, and more information is only possible that we as doctors try and include genomics in our practice and use the application or tools to enhance this subject better, because it's going to improve the delivery of healthcare. It is going to improve patient care a little better. So it's going to benefit the patients, the caregivers, the doctors. So it's going to be quite a symbiotic journey where everybody gets to benefit from it. It is also an additional application or tool in terms of revenue, as I say, because all other businesses, all other faculties, they keep on adding newer ways of making money, whether it's finance or whether it's industry. So we as doctors also have to think about newer ways of making money by improving healthcare, of course. Because I remember my father saying that if you do good care, if you do good health, if you practice the best manner, money always follows. Although money should not be the criteria, but better care is exactly what, or creating USPs will always help you in giving a better care, and money will always follow. So including newer technologies like digitization, genomics, cellular science to our field will definitely give us an added avenue for better economy as well. So a little about nature and nurture, where nature is what is we are born with, our genetics, which just tells us everybody is different. If I'm, let's say, 6 feet tall, somebody is 5 feet tall, somebody is 7 feet tall, somebody is 6.5 feet tall. So that we cannot change. That's nature. That comes with our genotype. But the way we express it, the color of your eye, your height, your predispositions, or you being a diabetic or etc. This is phenotype. So this basically is influenced by our environment, which we call as nurture. So nurture influences nature either positively or negatively. So if you do good, you're going to have a good body. So yes, that's a positive one. If you eat bad food, if you have bad habits, it will affect you negatively. So nurture is an important fact. Now nurture helps the gene expression improve or reduce as we go along. So I've just drawn a diagram below, genetic versus environmental below, which were the problems due to genetics. These problems are purely due to problems in the genetic code. However, environment influence on your particular genomic leads to exposure to tuberculosis, diabetes, etc. These are lifestyle issues, and These are infectious issues which are external. So this is what we have in terms of whatever. So there's another very interesting fact I'd like to mention before I go on to a little more into genetics, that we have had a few seminars where a few people mentioned that ignorance is bliss. Don't tell me if I have cancer. Don't tell me I have a predisposition to diabetes. I'm happy with what I am. So I said, but yes, we went to school because we want to get rid of the ignorance. Our parents got us into school because they didn't want us to be ignorant. Now, in banking sector, we do the KYC, know yourself, know your customer types. So knowing your DNA, KYD is how we refer to it, will help us create a health audit. This awareness is euphoria because it not only tells us about our issues, it helps us plan our health in a better manner so that we are ready for it. In terms of health, we can probably do more exercise, have better food, or save some money if eventually we're going to have some issues, so that it does not take us by surprise. So it is always important to be aware rather than ignorant. It comes in very handy, where genomics is a big role. Of course, family history and clinical practice does help us be aware in terms of these future issues, but genetics is a little more precise and personalized in this manner. So, oh sorry, Vishwajit, how do I go back? So genomics plays a very vital role and an important role in deciding individuals' health outcomes. So they decide. So we, as using digital platforms, we have created genetic predisposition scores. So these scores basically tell us that what is the likelihood of us having a particular issue and the amount of effort that we need to put in to manage that. We will, again, as I said, we will come into these detailed facts with our next speakers. I'm just briefing everybody of the terms and things that we need to know. I'm just making people aware that what genes do and what how it can be useful, etc., so that we can approach it in a little more informed manner. What we didn't mention in the basic stats was the single nucleotides, those bases. Now, single nucleotide polymorphisms, called as SNPs or SNPs, typically referred to as SNPs, are the most type of genetic variations, because the genetic variations happen at those base levels. If there is a combination of AT and CG, instead it becomes GG and AA, or TT and GG. That is one difference. Now, SNPs at a single point are known as point mutations. Now, these point mutations don't really affect. What one gene does is basically create one protein. That's about it. I mean, it has to create a protein. The complexity of protein decides the complexity of the gene as well. So it could be one protein which probably codes for the color of your eye, or one protein that codes for the insulin molecule or the dopamine molecule. If the code is appropriate, if all the SNPs are in the right place, you'll have the right dopamine and the right insulin, for example. But if there is an issue with certain proteins, if dopamine proteins are not properly created, then it can lead to issues like Parkinson's. If the insulin molecules get disturbed, it can lead to diabetes, etc., etc. So knowing these single nucleotide polymorphisms is very important. They help predict an individual's response also to certain drugs. Now, I'll give you a quick example. A person, let's say, if he has a coffee in the evening, there are some people who will have coffee after dinner and sleep very peacefully. While some people have coffee in the evening, they're unable to sleep for a long time. So that coffee molecules affects a particular individual in a different manner. It is true about all your medicines. It is true about all the food that you eat, etc. Some people can have 2 rotis. Some people can have 8 rotis. Some people are happy with eating just rice. So people's responses to environment varies very individually. And it is true about drugs as well, and the way we treat a particular person. Now, this FTO gene, which is like a fat obesity gene, FTO gene, which basically codes for obesity. There are a lot of genes involved in that. But with mutation, when we know there's a mutation in this particular gene, it increases propensity for weight gain in that individual. So we will discuss genetics and genes and issues a little more detail. But this is, again, like I said, I'm just giving you a brief on how things are basically analyzed to achieve certain things. So your environment basically causes a gene expression. If a gene is expresses itself in the sense the quality of protein that it is creating or coding. If it is good, the expression or that particular function of that gene in the best possible manner. But it gets altered if you are consuming a lot of free radicals, if you have bad habits, then there will be pollution created around this particular gene. So the signal that is sent, I mean, if you can see me, if I put my hand over my mouth, my voice is not clear. But if I create a rupture, or if I take my hand away, so this is taking bad habits away, or eating the right things, then my voice is clear. So what I mean is, if we have the right lifestyle management, then the gene expression will be maintained better. What is happening is genes are your cells are replicated. We as human beings are replicating ourselves on a daily basis. So that next copy that is being made, if the gene expression is better, will be a good copy. That means there is no problem. But if the copy goes bad, it is also aging or senescence, or creating problems to different. So that gene expression improves considerably if epigenetic changes, that is environmental or external effects, are in the best possible manner. And these are very specific to individual. So knowing your genes or knowing your genomic profile is a very important aspect, because everybody will know. Like we see ourselves in a mirror and comb our hair, dress up, etc. We also need to have a look at the mirror inside. We have to see how we look from inside, so that we can express ourselves in the best possible manner in terms of our life functions. So this basically is which leads to lifestyle changes. When we say now, either is lifestyle changes or following good lifestyle is what we can achieve when we know how we are from inside. So as I just quickly mentioned, so I'll run through this quickly, that genes basically are responsible for protein creation. The quality of protein created is affected by environment. I will call epigenetics environment, just to keep things easy. So environment alters the way genes are expressed, silenced, or activated. So good genes can be activated, bad genes can be silenced. I'll just give you a quick example about a beehive. Now, in a beehive, there are bees which have the same genetic composition. However, there is one queen bee and the rest are worker bees. Now, although they have the same genetic composition, they function differently. They have different lives. The queen bee is fertile while the worker bees are sterile. Now, why does this happen? This happens only because in a beehive, the worker bees consume all the nectar and pollen and the honey, and they survive on that. So the food or the environmental effect that the worker bees has makes certain genes express themselves, and which leads to them being worker bees. However, the queen has the royal jelly. So at the center or the core of the beehive, there is a jelly, which is what the queen has. So just because she has a different kind of food, she stays fertile, as well as she has a way longer life. So it is fascinating how nature works. But it's the nurture, the royal jelly or the food, nurture in the sense the food that the worker bees or the queen bee has. It's a little different. So the nurture is what makes them a little different. Now, these are inheritable changes in phenotype. When you talk about phenotype, what is a phenotype? Your genotype is your genetic makeup. So your genes, basically the type of genes that you have creates the genotype, how you are, etc. But the way it expresses itself, as I mentioned, the color of your eye, your height, your weight, your predisposition, whether you're a sporty person, whether you're not, all the expression, whether you have diabetes or whether you are likely to have diabetes. This is part of the phenotype. So phenotype is the expression and genotype is the structure, if you can call it in a simplistic terms. Only certain pieces are activated or turned via methylation. Methylation is also a very important process in our entire metabolism, which will be discussed later. I think Dr. Amol will talk about methylation in much greater detail. But if you look at the diagrams, it just says gene 2 creating a protein, gene 4 creating a different protein. So let's say gene 4 in the lowest DNA, the gene 4 is switched off, so no protein is created. How is that switched off? By certain foods that you are consuming, the certain influences that you have, the certain, basically habits that you have, etc., etc. So I'll move on to the next slide now. So SNPs are the basic units, but basically every gene has multiple nucleotide bases, but they probably are similar. As we said, only 4% difference between chimpanzees and humans. Between humans itself, there's a 0.1% difference. So in going beyond that, there will be certain differences which make us look different. So not that entire gene would be different, but there'll be certain base points or certain individual points which will be different between two human beings, which help us basically decide that if a particular population has more than 1% of difference available, and it is expressed in terms of a phenotype that's considered as a important aspect, which helps, let's say, the WAS studies identifies these SNPs and then correlate the changes in certain SNPs to diabetes, or so changes in certain SNPs which causes cancer, or certain SNPs which keeps people healthy, but one is an athlete, one is more of an athlete than a football player, one is a weightlifter, or one is a swimmer. So all these differences are these differences in SNPs. Now, difference in color of your eye. So it is, again, you can say it's a mutation, or it's a polymorphism, as you would refer to this mutation as the difference in the color of eyes, which also will be discussed later on. So this polymorphisms is what makes everybody different. So it could be a healthy difference or a disease difference. So SNPs is a very important factor which also creates predisposition to certain range of pathologies such as obesity, cardiovascular disease, Alzheimer's. We will today talk more about obesity. We as Genescope.ai want to focus more on obesity on the onset, because as a metabolic syndrome, obesity has an influence on all the possible disorders, or a lot of important disorders which are basically plaguing our country at this point in time, especially diabetes and cardiovascular disease and cancers, etc., osteoporosis. Now, there is dietic resistance. Your body has certain function, the oxidative process, the detoxification process, the methylation process, or an inflammatory process. Now, all these are governed by certain genes, which will, again, as I said, will be discussed. The technical part will be discussed by a geneticist as we go along. But yes, all these functions in our body are also, as a matter of fact, controlled and driven by our gene or our DNA. Now, as we mentioned earlier, we Genescope.ai, with our primary focus, want to address the growing burden of NCDs. And using personalized and precise medicine, which is genomics, we will definitely make a big inroad in managing this best. And we would like to stay ahead of the world. So we really collectively need to address this in the earliest possible manner. Now, I will not go into much detail because we as doctors are aware of NCDs. I will just quickly move ahead. But yes, lifestyle issues, this is diet, sleep, exercise, stress, relationship, thoughts, etc. These are all functions in a body which are basically, we are, as we know, we're just a mass of chemicals. So any disturbance in chemicals, this and that, is the reason why we consume chemicals, which is drugs or medicines, and try to influence these processes in a better manner. And these are governed by a gene. So genes are a very important part in making this happen. Yeah, one sec. So coming to major technological advances, if you see on your left, we have mentioned susceptibility or the health propensity. On the right, when you move right, it is pathogenesis, disease progression or death. On the left is health. Now, genomics has to help us go shift left. As you can see that green arrow. We believe in creating this left shift. Now, left shift is towards health, towards prevention, more proactive approach rather than a reactive approach that we do in medicine. So genomics is going to help us be a little more. This is the most important thing that I actually learned or experienced as a part of health when I was 12 years in the UK. I was part of NHS. What I realized most is they have a very aware population. Prevention, getting to know things, and keeping yourself healthy is very important, because though they have the government service taking care of their health, which is free, there are long queues. So if you have to go to a private healthcare, it costs money. So to reduce costs of money, they stay healthy. Well, being healthy is more important than worrying about the cost. However, basically preventive health has a big big role in all the Western countries, which we typically lack. So genomics is going to help us that, which typically is also is guidance or consultation from our side in terms of patient. In fact, it'll also increase the number of OPD visits, because people will probably be addressing prevention and health more. So that shift left is better in terms of health, in terms of delivery, in terms of economy. So it is a great state to be in, which we are trying to propagate through this genomic science. So our approach is proactive healthcare management. The focus is individual health, and the objective is prevention and treatment and diagnosis at a very specific and precise level. We can tailor nutrition as per individuals, because the food we eat is also medicine, or the kitchen is our pharmacy as well. Besides, so when we land in a problem, yes, we are resorting to external methods, but we do have these applications or tools in our house. We also need to resort to having a good lifestyle is a very important aspect to prevent all the issues, as well as manage issues well while we are being treated. So application of genomics on the right hand side, prenatal or preconception. Now this is a fantastic test which is called as NIPT, the non-invasive pregnancy testing, which is antecubital vein. Like we take a blood sample for pathology test. We basically take blood from a pregnant woman at 8th week or a 10th week of pregnancy, where it is the earliest test in pregnancy, because there is free floating DNA cells. When they are destroyed, the DNA stays. DNA does not alter, does not change, does not die types. So there is free floating fetal DNA as well present in maternal blood. So that is extracted, and we can run a full screen, genomic screen on baby's health with a non-invasive test, which is a blood test rather than amniocentesis or ultrasound at whatever level if it has any issues, and etc. etc. Anything external is definitely bound to have some problem. However, having maternal blood taken to analyze a baby's health, baby's predispositions, baby's issues, knowing whether the baby is going to have rare diseases like Downs, Klinefelters, Duchenne's, etc. So genomics is a very important tool in diagnosis, treatment, managing fitness, understanding metabolic disorders, molecular stuff. In fact, even a lot of therapeutic decisions, especially pharmacogenomics. Genomics plays a huge role in this entire thing, and disease monitoring and management. You must have heard of liquid biopsies in terms of cancer. So identifying cancer either at an early stage, finding out secondaries, etc., much before detected by radiology scans and different tests, pathology tests that we do. So genomics is a very important application or tool which will definitely make a big inroad into clinical practice soon. So, and it is evidence-based. It's and the WAS is, and collectively, globally, everybody is contributing to this information because it is evolving at a fascinating pace. And this particular catalog or library needs to be utilized by everybody globally. So this is a centralized pool where all the information is going. So which we can create our own libraries, we can contribute to these libraries and be ahead, as I mentioned. So it is our responsibility as doctors in this country to incorporate or inculcate the genomic medicine into our practice on a different approach, address the preventiveness or the proactiveness of the entire care. It also targets the root cause, and it is a very sustainable outcome. So it is a sustainable way of looking at healthcare. Genomics is a very sustainable way of looking at healthcare. I will give you an example in terms of obesity again, where people do keto diet, some Dikshit diet, and Dandekar diet. Yes, it does. If you exercise, if you do diet, if you do the right things, obviously it helps, but it's never sustainable. It's called as the yo-yo effect. So maybe 3 months down the line, your weight again comes back to you. So instead, if you understand your genomics, eat the right things, do the right things, exercise in the right manner, which is more suitable to your body. Now, your body, if I compare it to a car, like once a car is manufactured, it does not change. It's like the DNA, the car is manufactured. The horsepower, whether it's a petrol car or a diesel car, and the horsepower that it has, it does not change. So you plan your trips, you plan your journeys, you plan your, the number of travelers in that car accordingly. Similarly, knowing your genomics, knowing your DNA will help you understand your lifestyle, whether you have whether you're a morning person or an evening person, the best food for you, which is suitable for your body, the intolerances or the insensitivities that you have in terms of, so you can plan your life journey in the best possible manner in this car, which is basically driven by the DNA. So genomics is a very important knowledge that every individual should have. But considering the costs and economics of the whole genome at this point in time, only based on health objectives, based on whatever your issues are, a certain part of your DNA and genes are tested at our laboratory, which also incidentally, I would like to mention that our laboratory is all the NABL and the DSIR and ISO certified. It's the most suitable, most certified laboratory, which does things in the more best practice manner. We are based in Pune. So this genomic test is a single test in a lifetime, because your DNA and gene doesn't change. If you do a whole genome, it's just one-time test. You can use that as a reference for the rest of your life. Even if you have certain objectives and you've done a certain part of genome testing, so that part of the genome is not going to change whatever you have. For that particular objective, that set of genes or that set of information is going to stay constant for the rest of your life, which will help us do a lot of intervention or a lot of addressing your lifestyle in different manners. It has got multiple benefits for the rest of your life. It definitely improves the quality of life. It improves health, fitness, and wellness, and in a sustainable manner. Having said that, because we're talking about the lab, we also do animal genomics, plant genomics, viral genomics. So we have RT-PCR lab, which has been doing the COVID testing, etc. Because this is all genomics and about identifying, the type of bacteria or virus it is, and there are a lot of clinical tests, etc. So we have that entire plethora of tests which we do through our next generation sequencers, capillary sequencers, etc. Which there's another slide to that, so I'll go in a little detail afterwards. So there. Now the role of a doctor or a physician that is needed in basically care, which includes prevention, early identification, diagnosis, treatment selection, and monitoring recurrence. Basically, general physicians guide patients in achieving this in wholesome. They also guide in type, because specialists, super specialists, hospitals, the kind of care that is available. This entire information, knowledge of information is with physicians. And it is very important for the physicians to connect with the patient in the best possible manner. So genomics, if it is an additional tool, if it's an additional application available, we should incorporate that as well. So that is an added benefit for the patient. It's an added benefit for the doctor itself, plus is added in a benefit for the caregivers. So all the points mentioned here, identifying disease, pre-symptomatic issues, the best approach, markers of new change disease. With this knowledge, the delivery of healthcare is basically uplifted multiple folds. And this is an integrated, it's an integrated approach, a holistic approach, where we have the clinical information through our basically history taking, through basically all the diagnostic measures like radiology, pathology tests. We also have that information. But to enhance that activity, so in fact, even these tests and this clinical information can be used as a reference. With the genomic testing, if we give us a more personalized approach and a particular intervention is done, we can have a referencing of pre and post. We will see it is a much better way of delivering care to the patients. So the genomic testing services, as I mentioned, we have the general physicians and clinical care teams where the test ordering, patient families, etc. is done, from which we get the samples. We look for the quality of the product, and when the sample is good, we say, yes, we are ready to go ahead, or we have to collect another sample. Typically, the best part of genomic testing is any body tissue part, whether it's a frozen sample, whether it's a biopsy sample, whether it is blood, whether it's urine, or basically fecal strata. There's enough cells available. But the easiest for a test is your saliva. considering your mucosa is the barrier, and it also has a lot of secretion of white cells. And as I mentioned, red blood cells don't have a nucleus, but white cells do have a nucleus. And we use salivary samples. We extract the cells, we extract the DNA from the cells, and the DNA is then probably hybridized, and then it is fed to the next generation sequences. So it's quite an automated, protocolized as per NABL standards. It is probably, it turns out good data and information, which helps us basically advise our patients or our clients. We typically have more clients because we have a lot of people coming to us with good health who want to just manage weight, want to probably improve on the sports capacity or sporting capacity. They just want to do some preventive because people are getting a lot of fitness conscious, health conscious. So not necessarily patients are referred to us by doctors. Yes, they are as well, but typically our patient base is addressing health. So we have a huge client base, which is also like I said, client base rather than patient base, which are addressing it through gyms, etc. We can personalize exercises and diets and nutrition through the testing. So this genomic knowledge base is not only used for that individual, but collectively it can be sent to these central libraries. There can be better research which can improve public health. It can improve policy making. It can improve. It has got a lot of advantages to the government, to the research organizations and different institutions that do that. So as a patriot, as a nationalist, we have to also contribute to this as doctors, being the health soldiers of this country, which we have to contribute to. So genomics is going to make big inroads in a lot of activities. So it basically addresses the entire healthcare ecosystem or exchange of information. And it will also improve workforce development and education, newer technicians, newer molecular biologists, newer labs, etc., which also aid in the healthcare economy. It will add value to hospitals and different healthcare centers. So genomics is quite an interesting subject to be part of. As I mentioned, to contribute to a healthy India through identifying things, reducing the cost of non-communicable diseases, which runs in trillions of dollars. I think if we can reduce or decrease it by 50%, I think we can compare with saving trillions of dollars and probably one of the leading economic powers in the country. So it probably can have an impact to that level. So as we said, shift left, healthy shift left, morbidity is right. So we have to work towards shifting left in the best side. So as a summary, your genes don't change. However, you can manage their expression by making the right nutritional, exercise, and lifestyle choices and the right clinical advice by the physicians. How is what we will see in the coming slides. So nutrigenomics is part of genomics as well. Clinical genomics, consumer genomics, the different oncogenomics, pharmacogenomics. Nutrigenomics, as I said, which is your food, which is your medicine, your kitchen, your pharmacy, which will be discussed in greater detail. But I will hand over this to our revered geneticist, Dr. Amol Raut. So thank you for listening to me. And one more question. I hope everybody heard what I said.
Yes, it was quite present.
Yes, sir.
Was it okay? Did I talk too much or?
No, that is quite right.
Yeah, thank you so much.
Yeah,
because I will
for enlightening us.
So one thing, if anybody has questions, can we leave the question and answer session for later, or how do you want to do this?
You decide, sir. I think at the end we'll take question and answer.
Yeah, so I think because if the flow is, while I've spoken all this, Dr. Amol will just keep the flow going with nutrigenomics and few other very vital things. And so I will leave the question answer session for later.
Yeah, we request rather all the delegates to put their questions in the chat box.
Yes, please.
Yeah, there are many delegates are on YouTube also, so they can also send questions, and one of your colleague may collect these questions, and at the end we'll have this question and answer session. Thank you.
Yes. Thank you so much. Thank you for listening to me, and thank you for Dr. Avinash Bondwe. I'd like to thank you again for helping us do this presentation, which will be mentioned in greater detail in vote of thanks. So over to Dr. Amol Rao, please. Thank you. How do I exit?
Very good morning. Can the audience hear me? Hello?
Yes, sir, we can hear you. Just make your screen as a full screen.
Sure, definitely.
Thank you.
Fine, I hope you can see the presentation as well on the full screen mode now.
Yes, sir.
Great. Okay. So I thank Dr. Avinash Gunve. I thank IMA CGP and the entire organizing team for giving us this opportunity to talk today on genomics and its application. I also thank Dr. Atul for giving a wonderful introduction to the topic. I know that when it comes to genomics and genetics, it is considered as a very heavy subject. It is considered as a very detailed subject. So definitely, Dr. Atul has tried to cover a lot of things in this brief time that he had, and has certainly made a point in making all the introductions about it. So now my job over here today, dear ladies and gentlemen, is to connect the dots between what this technology of genomics is, how is it going to be useful for a practitioner, how is it going to be useful for a doctor. This is going to be my topic. With this, ladies and gentlemen, good morning. This is Dr. Amol Raut. I am a molecular microbiologist. I've been in the field of molecular biology and genetics for now last about 20 years. And let me tell you, when it comes to genetics, usually we think that it's a very heavy subject, may sound a bit boring, but let me tell you, we need to understand the application of it. And my today's discussion is going to focus absolutely on why and when a practitioner should consider nutrigenomics or pharmacogenomics at his or her disposal. To begin with, let me ask some questions to the audience, and I'm going to request the audience. I already see that there were a few points in the chat box, and I'm going to request the panel member, the audience over here, to keep on posting their queries. I'll certainly try to answer as and when we are discussing this during the session. Now, some questions that I would want to post before we go ahead, which probably I think will give an answer why to use genomics. As a medical practitioner, I'm sure you come across day in day out, you come across cases of obesity, and people would be asking questions such as, डॉक्टर मेरा वजन कम नहीं हो रहा है, मैं सुबह मैं एक्सरसाइज करूं या ना करूं, मैं योगा करूं, or I should do gym, or I should run, or I should do walking, jogging. These are the questions that our patients, our clients ask. Besides, they would ask, doctor, I've come across different diet patterns. There is a keto diet, there is an intermittent fasting diet where I should eat only twice a day, and then there is a different mechanism of the diet where there are multiple meals. Doctor, which is the right diet? Okay, then followed by that, patients would also come and ask, complain that do whatever it comes, they're trying to reduce their cholesterol levels, but they are not been able to reduce their cholesterol. Maybe the patients have been put on statins, the patients have been put on all the drugs that are required to do so. The patient says that he has been reducing all the fat content from the diet, but the dyslipidemia is not under control, the cholesterols are not under control. These are the questions, ladies and gentlemen, doctors, I feel that you definitely come across on day-to-day basis. Now, the moment we come across such questions, with whatever time you have with you, you definitely try and provide answer to the patient. But somewhere, I'm sure that you would have also realized, you would have also understood that probably when this type of advices or solutions are given to the patient, it's not just that the drugs are going to help, there is some more guidance and handholding needed to the patient on the lifestyle aspect. Which diet, which exercise, how much time, which foods to eat and not eat. And that's where a doctor starts feeling that he probably is not able to spend enough time with the patient and give him all the required advice. Don't you feel that there should be a system which should be able to give a precise advice to the patient on lifestyle? which means that lifestyle disease management, be it obesity, be it diabetes, be it cardiac diseases, be it PCOD, or a simple thing such as gastric distress. Whenever such lifestyle diseases comes, in this case, along with the therapeutic mechanism, there should be a precise guideline on the lifestyle front as well. And audience, my topic today is to talk about what these lifestyle advice are. And secondly, is genomics going to help? Is genomics going to answer questions to these levels, such as which exercise is best? Let me not go to the which exercise. Let me, in the audience, while I proceed to the next slides, ask the question: do you feel that a question like which is the right time for exercise that can be addressed? Okay, so while I go ahead and ask, present the other slide, I'm going to request the audience to type in whatever their answers are. What do you feel is the right time for exercise when a person tries to lose weight? Whether the exercise should be done in morning or evening, fine. So we'll go ahead in the next way. What is this science nutrigenomics? We spent almost last 8 years in developing this science in the country, though the basic science of genomics is not new. It's been there in the world for the last 25 years, especially since the since the completion of Human Genome Project and so on. Oh, well, great. I've started getting responses. I've not seen them, but I'm definitely going to wait for some time. And I see that, okay, there's morning response. Fine. I'm waiting for the other answer. So I was talking about genomics when the Human Genomic Project was completed. It happened so that the Human Genomic Project opened a Pandora's box. It told that, look, there are a few million genes and gene points. Great audience. Okay, so that's great. I'm sure that all of you have started participating and providing answers. Morning. Okay, as expected, I'm getting a lot of morning answers. We see a lot of morning people. I would be not surprised if I see some of you evening, saying evening as well. So the Human Genome Project mentioned that there are a lot of genes present in the human body and they correlated something. Now, the wonderful thing that nutrigenomics did was it told that which genes are to be studied and whether those genes can be useful in telling whether a diet or a type of nutrition or a type of exercise or lifestyle choices can be made. The best option over here is to use this. What is the objective? The slide that, as it mentioned, the gene profiling can help in different ways in improving the health. Hence, from morbidity to a better healthy nature, definitely we can come. Now, the next question is that the slides, gentlemen, is going to be, ladies and gentlemen, is going to be used as a reference. The slides have a lot of material. The reason being, even after our discussion and the slides are shared with you, it can remain as a resource material, but you may focus on the bold points during the discussion that we have. Okay, so the question now is that, what is this genetic testing? The genetic testing, nutrigenomic testing, is a mechanism where Genescope has been offering it, where all the lifestyle diseases that people suffer from, a genetic testing can be useful in providing solution. So what this solution is, the mechanism is, or the objective is, first, prevention. Second, early diagnosis or prognosis. The third is diagnosis, maybe followed by that even treatment. There are certain cases where there is treatment that is possible. And finally, monitoring the recurrence. Now, these are the different objectives that a nutrigenomic testing is going to have. I'm going to elaborate on all of them, and I'm definitely going to tell that how does a genetic testing help in prevention? How does it help in early identification, prognosis, and diagnosis, and so on. Now, this science is an evidence-based science. The other important thing is genetic testing, fortunately, is to be done only once in a life, okay? Because our genes don't change. Followed by that, it's not just a preventive approach, it also can be considered as a proactive and a personalized approach. Why? Probably the questions that I was mentioning earlier, when it comes to personalized, there are questions that cannot be generally or generically answered. So coming back to the question that I had asked, that what is the right time of exercise? I saw that there are many answers saying that there is morning time. Okay, very good. So I think a majority of the members in the audience who chose to respond, they say morning time is a good exercise time. Now, I would want to make a mention over here that when it comes to genetics, when it comes to use of genetics in lifestyle disease management, Just a moment. I think there is some glitch in the presentation. Yeah, take it. Right. When it comes to lifestyle disease management, genetics can tell a simple answer such as which is the right time for exercise. There is a gene in our body called as clock gene. Now that clock gene tells whether a person will respond to exercise better in morning or evening. So which means that if there are, let's say, around 30-40 people over here in the audience, some of us have a clock gene of the nature that we will respond to exercise better in the morning. Some of us would respond to exercise better in the evening. So which means that some of us have an evening clock gene and some of us have a morning clock gene. Now, the same happens with our patients as well. Those who are struggling with obesity or lifestyle disease management or losing weight or insulin resistance for that matter, if they have to choose the right time for exercise, they ideally should choose it based on their clock gene, which is nothing but it controls the circadian rhythm. So a clock gene can tell whether a person should exercise in morning or evening to get a better response. Now, just imagine a case of stubborn obesity. A person is struggling with weight loss, has not been able to lose weight, and such individual one fine day decides to get up again in the morning, restart exercise, goes to the gym early at 5 o'clock and so on, starts exercising. He's not getting good benefit, he's not losing weight, probably because his gene says he should exercise in the evening and he has been doing early morning 5 o'clock exercises. Whether it is yoga, whether it is gym, whether it is cycling, doesn't matter. His time for exercise is evening because his circadian rhythm is set in such a way based on that gene that he has a tendency to sleep late and wake up late. Now, such individual whose metabolism is going to wake up a bit late, can we expect such person to get up early in the morning and have a better exercise response? No. So the next time when patients, you see a patient saying that I'm not able to lose weight, I'm exercising so much, the next question that we should ask ourselves, is the patient, is the client, is the person working out at the right time? Clock gene, one of the gene amongst the 1,000 genes of gene present in the body, can give that answer. And this was the answer that was given by many genes that were studied in the Human Genome Project. This is what brings us to the science nutrigenomics. So you can see that there are two broad terms over here, nutrigenomics and nutrigenetics. Very simple. Nutrigenomics is the science which tells that how food and environment has an impact on our genes and how does it govern our metabolism. Let me give an example. Obviously the question is that, oh, is it so that the environment or the food will have an impact on genetic makeup? Of course it has. I'm sure you see so many people who would come and complain, Dr. Saab, I'm suffering from a lot of gastric distress. I suffer from acidity, bloating, etc. and so on. You know what probably would maybe happening in that patient? That patient probably is a case of gluten sensitivity. I'm not saying gluten intolerance. He may be a case of gluten sensitivity. Maybe his genetic makeup is such that when he consumes gluten, gluten is a protein present in wheat and many of us know about it. Okay, so whenever that person consumes gluten or wheat and that gluten enters in the intestine, the gluten has a ability to trigger inflammatory response in the body. Now, this is what I say that food has an impact on gene. And yes, day in, day out, the moment gluten enters in our body, your body, my body, it's able to trigger inflammatory responses. In some people, it is seen in form of acidity. In some people, it is seen in form of bloating. In some people, it may be seen, you'd be surprised, in form of acne. In some individuals, especially in women, during the pain that is experienced during the menopause, menstrual cycle, initial days, gluten triggered. So food has a capability to trigger gene expression. That science is called as nutrigenomics. The solution is we can understand whether that person is sensitive to gluten or not and advise how long that person should stay away from gluten, whether the person should quit gluten completely, is there any antidote possible, etc. Now, similarly, there's another science called as nutrigenetics. Let me draw the attention of the audience to the other topic, that is nutrigenetics. Nutrigenetics tells us that based on your genetic makeup, which are the right nutrients required for you. So I'll quickly go back to the earlier point where I mentioned that there are certain foods which enter in the body and which trigger certain gene expression. Similarly, based on our genetic makeup, we have certain requirements Okay. While for the gluten, I could give an example of somewhere around 7.5 thousand people for whom we did gluten sensitivity testing pan India in last couple of years. Let me give example of a couple of thousand people whom we tested for their requirement towards vitamin B9. We all know, ladies and gentlemen, doctors, that vitamin B9 is available in two forms, folic acid and methylfolate. Conventionally, it is known as folic acid, the general vitamin B9, and methylfolate is usually known as the bioactive version. Now, we decide to recommend, most of us decide to recommend methylfolate over folic acid or one over the other based on the benefits of bioavailability, the other nutrients that it packs, etc., etc. Let me tell you, there's a genetic angle to it. There are around 30-35% people whom we have seen in more than 3,000 cases who will not respond significantly to folic acid. They need methylfolate. So when such people show their homocysteine levels are high, I'll repeat, when such people, their homocysteine levels are high, B12 is not the answer. I'll repeat, B12 is not the answer. The answer could be whether folic acid or methylfolate that goes with the B12. How will we be able to know that? One way is, okay, random, try methylfolate for few days and then try folic acid for few days. But this person, if he or she has a mutation, a genetic mutation in the DNA such that she needs methylfolate, won't it be advisable to understand what that mutation profile and give a lifelong advice that will help in controlling homocysteine for a longer time? Won't it be useful in improving the cardiac health in that individual, or reducing the risk of recurrent pregnancy loss in a woman? Yes, it would. So this is how both the nutrigenomics as well as nutrigenetic science helps. Now, when I was talking about the nutrigenomics and nutrigenetic science, I'm basically talking about how diet or nutrients have impact on gene. I gave example of gluten sensitivity. Similarly, there is lactose sensitivity. Talking about lactose sensitivity, I'm sure that there are many people who would come and say that, doctor, when I am in a particular city, I do not suffer from digestive health issues. But the moment I shift to some other city and start staying there for a longer time, I start suffering from acidity, bloating, and gastric distress. A couple of interesting examples that we have seen, some of the patients who were consulted by our team of clinical nutritionists. We saw that whenever the person shifted from India to some other place, okay, that individual suffered from lactose sensitivity, and that lactose sensitivity was genetically covered. Okay, so in such cases, genes would help us understand whether the person has a lactose sensitivity or not, and then in such case, maybe the probiotic, etc., version would be given would be the right option. So yes, gene diet interaction is an option. Now, basically, in the science of nutrigenomics, what we try to understand is how environment has an impact on the body, and how based on this impact, whether there are any changes that can be made in the diet, exercise, and lifestyle. There's one more term that Dr. Atul did mention about, and I may not be able to give enough justice to it during this presentation due to lack of time, and that is epigenetics. We have heard a lot about epigenetics. Do we really need to know about epigenetics? While we talk about epigenetics, I would quickly give an example of one of the research project which I'm a co-investigator in, that is being funded by Ministry of Ayush, where we are trying to check whether yoga has an impact on gene expression. Okay, now, does yoga have an impact on gene expression? Yes, the hypothesis says that if a person starts performing yoga, it is known to trigger changes, beneficial changes at the genetic level. This hypothesis was there, and we thought that we should be the first in the country, in the world, to do this kind of research, and we did it. For 3 years, we were studying pre-diabetic population, control and study groups, and try to understand if yoga as a therapy was, or a treatment was given, does it bring any desirable change at the genetic level? Is it going to trigger some good genes on? Is it going to trigger some bad genes off? Interestingly, the summary of the results is, and we'll be soon publishing our results, the summary of the results is, we could see that there are desirable changes. You know what? Which means that when people perform yoga, people do get beneficial genes triggered, which may help in reducing the risk of type 2 diabetes. Okay, that's how it is. So, like nutrigenomics is a science that deals with diet, gene, and understanding which diet will be better, etc. There are other sciences which you may come across, which have been listed over here. We are not going to discuss about these sciences, but I'm just trying to mention because you may come across. Genomics is one which revolves around understanding genetic. The other is transcriptomics, proteomics, and metabolomics. Transcriptomics is understanding which gene is being triggered on and off. Proteomics is understanding whether that protein is produced or not, and metabolomics is overall flux of different molecules that are produced, the gene expression levels, and so on. Let me tell you, audience, over here that there's one more science which I have not mentioned here on the slide, but that science is microbiome. So what is microbiome? Microbiome is a science where we try to understand what is the gut profile of an individual in terms of microorganism, whether there are enough beneficial organisms or there are bad organisms, and how to manage them or how to change them so that the health issues are resolved. I'm afraid that gut microbiome is not a clearly or much comprehensively studied science yet in the country, and hence probably we may have to do some more research till such time that we come to a conclusion and start talking a bit more detail about it. But yes, genomics definitely, because this is absolute science, it doesn't need a relative information, and sufficient evidences are available around. Now, what is done in nutrigenomics? So when I said that whether a person is morning type or evening type, whether a person will be sensitive to gluten or not, whether a person is sensitive to lactose or not, and we can check this from genes. What do we actually check? We check that whether the genes that a person carries towards response to these nutrients, or the genes that decide whether a person will be deficient in a particular nutrient or not. What we check, or what the science checks, is presence of a variation. So what is variation? Variation is change from abnormal. And as you can see over here, that there is a slide where you can see that there is sequence of nucleotide. Whenever a person has a variation from the normal to abnormal, that is called abnormal, or less normal, we should say, less common. It is called as SNP, single nucleotide polymorphism. Sickle cell anemia is known to all of us. So what is sickle cell anemia? It's a condition where just a single nucleotide change in the DNA structure causes the change in the hemoglobin structure, has an impact on the RBC structure and ability to absorb oxygen, and hence results into anemia. So similarly, SNPs or SNPs, the SNP or SNP, it's the same, you can pronounce it either way. SNPs have impact on metabolism, and nutrigenomics, or the other science, pharmacogenomics, focuses on understanding what are the SNPs present in the well-studied gene. Will it tell more about diet, exercise, and so on, and how we can use it. Now, hence, we can say that yes, the SNPs that we study, they can tell us about nutrients, they can tell whether body can process foods or not. It tells about whether liver will be able to perform a good detoxification pathways and so on. Now, I'm also going to ask the audience while we discuss that for a better detoxification, I see that there's quite a lot of use of curcumin these days. We see that, yes, and especially during COVID, hats off to all medical practitioners and doctors like you who have worked day in, day out, worked hard to help people overcome. People were also concerned about their immunity, and they were asking questions such as, doctor, should I consume these nutrients? Should I consume XYZ nutrients? And they were surrounded by a sea of information. Curcumin was one of it. Curcumin was supposed to be one of the wonder molecules. Now, and people started consuming curcumin rampantly without even probably asking the right expert at time. Only a subset of people will be able to digest curcumin. Curcumin should necessarily go through liver, and it should be metabolized in the right way. And some people simply lack that metabolism mechanism just because they have SNPs in their detoxification mechanism, which doesn't allow them to effectively digest curcumin. So in such individual, rampantly eating curcumin supplement may not be a good idea, okay, because it may create a pressure. So in such individual, okay, turmeric is good. Why? Because it contains very less amount of curcumin, probably the amount that is desired, probably the amount that is required. And hence the bottom line, or the gist of this probably slide, is that empirical consumption of nutrients is also not a good idea. Okay, people are surrounded with sea of information. Should I consume vitamins? Should I consume antioxidants? Should I consume their over-the-counter available? Even if they are not therapeutic, even if they are food-grade supplement, should I consume them? Well, I would, I mean, with the 18, 19,000 people that we have seen, we have done genetic testing. I would say that no, we cannot say that to go ahead and consume it rampantly. There's no challenge because there may be some people who may not be able to simply metabolize it. Okay, so that's there. Now, of course, we are going to also talk about how genes affect the fat metabolism, sugar metabolism, because specifically we want to talk about obesity. So nutrigenomic testing, it tells many things about which foods have impact on genetic makeup and which foods are better and which foods can fulfill the deficiencies. Now, it also tells something more interesting, and that's about eating behavior. A couple of years back, I'm sure that everyone knows that when it comes to questions like obesity management, there's a simple question that people ask. There's a very interesting debate or a 2-point theory that was happening. That one set of people were saying, experts were saying that eat only twice a day, intermittent fasting, keep a gap of 8 hours, and that's the best way of losing weight. Because you'll be able to control energy intake, insulin balance, and hence, yes, you eat once and then you keep a gap of 8 hours, you eat, have the second meal, and then for 16 hours you don't have anything. Intermittent fasting, good way of controlling portion, calorie intake, and so on. It helps some people. On the contrary, there are some people and there are some experiences by people who are trying to control their weight, lose weight, and control sugar. What they did is they didn't follow the intermittent fasting. They started eating small meals multiple times, 5 times a day, 6 times a day, small meals with less gaps, 2 hours, and they also could lose weight. So the problem now was that a person who has probably not tried either of it is in a fix, whether he should or she should try intermittent fasting or the other option, is that is the multiple meal. The answer is not only on the choice or decision. The answer lies in the genes. There is a gene in our body known as MC4R, snacking tendency gene, melanocortin 4 receptor gene. This gene tells whether a person has a snacking tendency. Now, if there is a variation in that gene, look how the logic says. If the person has a mutation or a variation or a SNP on that gene, the person will have a higher snacking tendency. And if the person has a higher snacking tendency, that person is going to demand food every now and then. Just imagine, will we be able to, in a sustained manner, put that individual on an intermittent fasting diet? Can we ask that individual to follow only a 2-meal pattern lifelong? No, we may not be able to. Okay. In fact, his body, his psychology, his metabolism demands low chunks of calories and food intake every now and then. So the right option for him will be multiple meals. For those who do not have that mutation, good, they may benefit from this. So if someone asks me today that which is the right diet pattern, of course, though I won't be the right person to decide that. The nutritionists and the dietitians would be. But from the genomic point of view, I'll say that the answer lies, one of the major answers will be from the genetic makeup. So, dear audience, genes will not just cover how govern how food will impact with your genetic makeup and metabolism. Genes not only decide the deficiency, genes may also be able to help us in understanding what should be the eating behavior, the feeding behavior. Okay, and also, of course, the fitness factors like which exercise is better, whether morning clock or evening clock is done, and so on. One more piece of information: if a person has an evening clock gene, and around 40% people have an evening clock gene, that person should not have a carbohydrate-rich breakfast, because the metabolism is sluggish in the morning. People tend to sleep late, and hence, once that person gets up in the morning, the typical saying or the advice, eat breakfast like king, I'm sorry, it's not applicable for such individual. Why? Because they have a very weak, sluggish metabolism in the morning. They do not need significant amount of carbohydrates. They would need carbohydrates more towards the evening when their body starts firing up, and they'll need more carbs at that point. So this is how it works. Now, while I was mentioning names of some genes which may sound Latin and Greek, there are some, this table, it highlights some names of certain genes over here. Please pardon me if the table is very small and it highlights some names of genes. But what I only wanted to mention is that there are genes such as ApoE, apolipoprotein E, which decides whether a person will have a tendency of dyslipidemia or not, which nutrients, which food will help in controlling cholesterol. Then there are genes such as FTO that tells which helps in understanding whether carbohydrate or fat, which is going to be a major contributor towards obesity, and hence the protein carbohydrate fat ratio can be defined. So when we talk about genes, what they do is Every gene has a unique ID, then every gene contributes to some or the other understanding of the health issue. And then what we understand is based on that individual, is based on the type of mutation profiling, whether the person is going to have, let's say, an evening type metabolism or a morning type metabolism, or when it comes to cholesterol genes, it tells which nutrient, whether omega fatty acids from fish oil will be a better source, or omega fatty acid from non-fish oil will be a better source, and like that. So this is the type of information that is gathered. Hence, when it comes to giving the personalized advice, because we started from the question that what is the right diet, what is the right exercise, when it comes to personalized advice, when it comes to right advice, when it comes to more systematic advice, can we use genetics? Can we use genomics? Yes, we can use genomics. Why? Because our answers will become more fine-tuned. So the next time we see a stubborn case of obesity, diabetes, the PCOD, or maybe fatigue, gastric distress, can we use genetics? Should be a question that should come to a doctor's mind. In such case, genetics will definitely help. I just thought that I should take example of obesity and quickly summarize this, that how genetics will be helpful in obesity, probably more. So obviously there are multiple researches that have been published in various journals, which say that there are certain genes that help in various factors, deciding meal pattern, deciding protein, carbohydrate, fat, and so on. Dear audience, let me tell you, when we have food, the challenge in front of a person who's trying to lose weight, I'm giving example of obesity repeatedly because that's a common problem. And let's say, for example, a person is trying to lose weight and his plate has 2 chapatis and rice. You know what? 2 chapatis, rice, both are carbohydrate. He also has to supposed to have, let's say, butter or ghee on it. Whether that butter or ghee is going to contribute to obesity more, or it is the carbohydrate that's going to contribute, the genetics can tell. If this information is with that person, the right dietitian, etc., will be able to understand. So obesity, there are many such challenges, and a systematic method, genetics, can definitely help it. So what we have observed is, and the studies or the data at our end says that, and also data that was published. So if genetic information is used, the weight reduction is efficient, more efficient, maybe 2.5 times more. When it comes to overall weight reduction, circumference reduction, it's 2 times more. Now, where do these numbers come from? The numbers is very simple. With the help of genetic analysis, we have one more reason to design a diet, exercise, lifestyle pattern. We have one more personalized way to design, and hence the efficiency increases. So let's consider nutrigenomics as a diet tool, because otherwise, as you can see over here in this slide, obesity is not just eating less carbohydrate and less fat. It is not just exercising more, it's very complex. So leave that complexity to a certain extent on people like us, who will be able to maybe analyze all those factors, convert it into information that is translatable, and then on the diet, exercise, lifestyle front, give advice to the patients so that when a doctor tries to work on the therapeutic aspects of the patient, the diet, exercise, lifestyle pattern can be a much more fine-tuned and a systematic method to be followed. Some of the genes used in controlling obesity, I think we have discussed this. MC4R for the snacking tendency. FTO are told about the carbohydrate, protein, fat. There's another very interesting gene, PPR gamma. It tells whether saturated fat will contribute to central obesity. Is central obesity not a very common thing in India? Of course it is. It's very common for us to see visceral fat. It's because people have mutation in this gene. And likewise, there are many. Now, all these while, before summarizing, I was talking about some genes. If they are tested, we can understand more about the person and we can give some advice. But let me also tell the audience over here, or bring this to light, that there are some genes which we can know more about in terms of information, but unfortunately we will not be able to give a lot of intervention on it. We will not be able to give suggestions or changes. PPR gamma, this slide I don't think we may have time to discuss over there, but I'll quickly go to a molecule called as leptin. Leptin and ghrelin, these are the molecules. We know that there are, a balance of it is used in hunger determination and so on. Now, there are certain mutations known in the leptin related gene, though they are rare. Let me tell you, these are the genes that are responsible for morbid obesity cases. Unfortunately, till date, we have not found interventions on it. That we know that when it comes to mutation in FTO gene, we'll be able to make some changes in the diet. When we know that there is a gene that tells whether yoga is better or gym exercise is better or jogging is better, we can tell. But there are some genes where there is no actionable information possible. So the next time a doctor looks at a genetic test as a tool to use by for his or her patient, we also need to understand that whether that genetic test gives actionable information. Because if it's just going to tell something that's, oh wow, worth interesting knowing, but it doesn't carry any value in the life of that individual, let's not try and use that information. Okay, so every information, every type of testing that is done should carry actionable information, and a right nutrigenomic test will always have that. While there are many organizations that are mushrooming up these days in terms of genetic testing, this is a choice, this is a filter that a doctor can have at his or her end. And hence, finally, when it comes to weight loss is not just reducing sugar, reducing fat. It is lot many things. It is weight management, it is controlling inflammation. Too much of exercise is not good. Detoxification, right liver functioning, right exercise. Too much of exercise, as I mentioned, is also not right. And a balance of all this. This is how it helps in man. And while this is being done, let me tell you why probably nutrigenomics or such approaches are important. Not just because they are going to be one time, because people feel that the diets always are to be followed for 2 months, 3 months, or 4 months. Diets do not have expiry date. Diets are our lifestyle. They should be adapted as lifestyle. And the role of a right nutritionist, right diet expert, right exercise expert, if it is governed by genetics, it helps in bringing practical solutions. Solutions, methods, approaches that are sustainable, that can be followed lifelong. So if a diet is going to be there only for a couple of months, it's not going to help. It should be sustainable, and a personalized approach will bring sustainable option. Fine. We had a case study to discuss, but I don't think we have time enough. I'll just take you through some of the reports. Let's say, for example, this is how obesity analysis is done. As you can see that fat absorption, metabolism, obesity, inflammation. As you can see that these are different factors, there are different genes that are analyzed. What role of nutrigenomic analysis or molecular biologists like us is to analyze all those genes and come up with a score. Now this is called as PRS, polygenic risk score. What is a PRS? A polygenic risk score is a summary of all the genes that we study in a particular condition. So let's say if I'm required to talk about inflammation, I'm not going to study one gene of inflammation. I'm going to just study genes such as TNF alpha, interleukin 6, CRP. Okay, there are various variants of it. And based on the result of all of it, based on the evidences present, based on the data that we have at our end, we have designed a PRS, polygenic risk score, or a risk score, not every time a risk score, or an interpretation score. Okay, which we call it as a rating. And based on this score, we can tell that sir or ma'am, whether you're likely to have high inflammation or low inflammation. Would you need anti-inflammatory support from diet, or you would actually need more anti-inflammatory support? Hence, maybe a supplement is needed for you lifelong, and so on. Okay, the same about multiple factors, whether it is snacking pattern, whether it is cholesterol, whether it is satiety. We've seen people who go to buffets and they start, taking meals on the plate. You'll see people that they will ensure that their plate is full with each and every item on the buffet. Okay, that's because psychologically they are given a response that unless and until my plate is full, I will not psychologically feel full, and then they start eating. So these are the things that are genetically governed. Let me tell you, right nutritionists, trained nutritionists have these things available with them and know how to handle them. I'm glad to mention that over last 8 years, we could train and we could teach nutrigenomics to around 1,000. Okay, 1,000 people. So, and hence, there are 1,000 touch points in the country today who have understood nutrigenomics. They could, they could use nutrigenomics. They could translate it in diet, exercise, and lifestyle. So these are the different diet parts. Similarly, there is on exercise front also, which exercise is right, whether gym or jogging or cycling or yoga. So those people who have sensitivity, I'm touching on the case now, that when those people who have a sensitivity towards high intensity of exercise, telling them to go to the gym and start doing strength training is not a good idea. If the person has a good responsiveness to exercise, if a person has high inflammation tendency, the right suggestion for that person will be do yoga and meditation. And at the same time, also tell that person that, look, that weight loss response is going to be slow. Do not give up, because your body needs this type of exercise. exercise. On the other hand, if the body makeup is such that the person is going to need high intensity, we'll have to tell that, sir or ma'am, do not walk for miles together. It's not going to help you. 1.5 hour of walking is not important. For you, 20 minutes of strength training is important. That is what is going to help you. That is what is going to help you jump off the plateau. So these type of understandings or learnings, they come when we have the profile of that individual present, and that is what makes the individual more clear that, okay, this is my genetic makeup, I need to follow this, no excuses. Okay, so the science of understanding what problems the person has, what is information stored in his or her genes, is something that's going to be useful for the diet exercise experts on duty. For a doctor, if you come across, as I mentioned earlier also, you can come across cases where people have such issues, be it any lifestyle disease, diabetes, obesity, PCOD. Unfortunately, we may not be able to help a lot of cancer patients directly, but yes, post-cancer or while they are recovering, care definitely can be taken. But for the other lifestyle diseases that I mentioned, based on the genetic makeup, personalization of diet, the pattern, the nutrition, the exercise, and the habits definitely can be. And this can bring in more precise analysis. Now, how this is actually done, Dr. Atul has been talking about genetics and SNPs. I've been talking about how this science is done. There are very simple 4 to 5 steps. The moment you come across an individual who probably you feel needs this, what should be done? Such individual, like we have spent around 45 minutes, 1.5 hours till now, understanding genetics and nutrigenomics. And next we have in line Dr. Kedar Joshi, who's an expert in the field of how the same information is useful for deciding drugs. Now, when you come across such an individual, how is he or she going to use it? When you feel that any person needs it, and that person should be connected with someone known as nutrigenomic counselor. Who's a nutrigenomic counselor? This person could be a trained dietitian or a doctor. Okay. We have, as I mentioned, we have trained quite hundreds of them in the country. You can connect with us and they could be there. Now, this person, the objective of this person is going to talk to the patient, talk to the person, and understand what the challenges are. And this process is called as pre-test counseling. We understand what the challenges are, what the concern is, and based on that, the first thing that we tell is whether a nutrigenomic or pharmacogenomic test will be useful. If the concerns are such that a nutrigenomic testing or pharmacogenomic testing has limited information, we upfront, right in the beginning outset, tell the patient that, sir, we may not be able to help you much. Okay, so that the patient is clear about it. If it is useful, we tell that, okay, this is how it is going to be used. I'll give an example. We have 2 people, both of them suffering from obesity, both of them desperately trying to lose weight. One has tried weight loss options with several advices earlier, and the other has never visited a dietitian or a doctor for weight loss. Okay. Now, the right person for nutrigenomic test, according to me, is the person who has tried and tested a lot many times. He has gone on multiple diets. He has followed some diet pattern. He has followed some advice, and yet he has not lost weight. He's a stubborn case. He definitely will be more motivated to do it. The other case where he's never taken advice, maybe the person may benefit from a simple diet advice. Not that genetic test will not help him, it will definitely help him. Who will be more motivated? A stubborn or a resistant case is more motivated. So this protocolized discussion counseling is called as pre-test counseling, which is done to tell patient whether a nutrigenomic pharmacogenomic test will be useful or not. If so, how? Then this helps in finalizing the panel or the test. And once that is done, with that cognizance, the person provides saliva or blood sample, whatever is feasible, and then it is taken for genomic profiling. Once the entire testing is done, the entire report, the glimpses of which I showed earlier, is in a detailed manner explained by the diet expert, exercise expert, and a hand-holding program for around 2 to 3 months is given to that. That looks, sir, you need to follow these diet, these pattern, etc., etc. And there is a continuous contact that is required with that individual, because that cannot be explained in one day, and it cannot be followed by a person in one day. It needs hand-holding. So we'll do that hand-holding. The same counselor who has explained the report is the right person to do that. And while the person is on that program for 2 to 3 months, this is where we expect that the person has understood his genetic makeup, has tried to follow the diet exercise program, and has now started seeing the result. So at the end, what I would definitely want to mention is, this is where, ladies and gentlemen, dear doctors, I come to the end of my topic. And thanks for your tremendous patience. I know Genomics is not an easy topic. I've spent 22 years in the field of genomics. I do understand what it takes to have patients in this field. But my entire objective in this presentation after Dr. Atul's was to explain that how a doctor can use or identify who needs a nutrigenomic test and how to connect that individual to a counselor who can probably take it right ahead, and that the diet exercise counseling part of it will be taken by the counselor. The therapeutic is still to be taken care by yourself. With this, I once again thank IMA CGP. I specifically thank Dr. Avinash Bondwe. I thank all the office bearers and the committee members for giving me this wonderful opportunity. And thanks to the audience also in participating and talking in the program. And over to you for the next part. So
Thank you, sir. Before that, we would like to welcome our immediate past national president, Dr. Jayalal sir. He is a strong supporter and our advisor for this IMA CGP activity. I would like to say a few words of blessings to us, sir. Thank you.
Thank you very much, Dr. Avinash Bondwe, the very dynamic and enthusiastic Dean of IMA College of General Practitioners, the Secretary, Dr. Anburajan, Dr. Rega, Dr. my classmate and brother, Dr. Anburajan, and our distinguished members and the very, very learned speakers. I'm extremely delighted and happy to note that IMA CGP is organizing this wonderful program on the genomics for the general practitioner. I think this is a very, very important topic which you have chosen today, which the importance of the GP, when most of the general Western countries has already made it mandatory, and the important for the GPs to know about the genomics. And recently read on studies, genomic reference for the testing. 1/3 of that is coming mainly from the GPs. To that level, the GPs are now well established to knowing the genomics. So at this contest, CGP taking the first step to see to that the general practitioners of our country is going to get widespread knowledge on the genomic is a very, very important thing. As a surgeon, we used to say in the olden days, we used to remove the limbs, or the if somebody has a problem with the one issue in their limb was removed. When the age comes of the organ is removed. When age comes, we made the diagnosis based on the tissues, and tissues were removed. Then we are now reviewing the area where we are now doing the FNAC and that cell. But today, the next generation is going to study on the molecular level and understanding how the individuals are going to get each disease, and going to make it a more personalized medicine, or the precision medicine, which is going to take individually in a collectively speaking, then how the individuals are going to benefit it. We have a tremendous impact of this genomic studies. I'm thankful to the speaker, which has covered almost all subjects. And one area is that on the gut genomics, and that is becoming a very important field in the study. Especially, we were able to even predict many of the cancers. Actually, a lot of studies has been done on the breast cancer. Even in Tamil Nadu, we have started a project on that, and the genomic study on the identifying the people on the cancers which we are going to develop. And also to some extent, the genomic studies are even putting the interrelationship, how our progenies and who were our predecessors, from where we have originated. So a lot of details are getting into that. I'm sure that this will open a new area of the field where we will going to do that. And most of the tumor markers which we are studying, and people, when we are talking about the BRCA1, BRCA2, or many genetic factors which is going to help us in early diagnosis of the disease. And also, as he has very much said about the genomics, where we are going to talk about the drugs, how they are going to interact, whether this drug is going to help or other drug is not going to help. So all this is not on theory. It is a practicality which has been happening in that, not only in the metropolitan areas, now even in the district levels it has come. Now most of the time, they do the genetic testing, the mama print or the type TX, so which will be able to not only say that whether this patient, how long he is going to get the disease, if the disease is there and how he is going to get the recurrence is going to come or not, and what type of therapy it is going to help. So all this is being now becoming a practical. So only thing it has to reach the general practitioners also. Many times the general practitioners we come across on the diabetics and how we are going to predict, and when the father and mother is have a genetic and diabetic and how he is going to do that. The mental health, when the father and mother has a schizophrenia, whether the child will having to have the 40% will have the schizophrenia, and autosomal dominant. All these are well-known facts, and now everything has to put together and able to make a proper diagnosis. One very much important area where we are talking now about the liquid biopsy, where even the cancer time when we are taking a treatment, whether we not go for biopsy always, we can even take the blood from the DNA. We will be able to come across whether this patient has the tumor or cells are still present, and whether the patient has a recurrence or whether the patient has the tumor is there. So liquid biopsy is also another area where we are able to get a lot of good things. So I'm so happy that IMA CGP has taken up this very important topic, and very learned colleagues are expressing the field. I will only request the speaker and give an algorithm at the end. And you have talked a lot about the obesity, what are the options there. But say that if the patient comes, how we will be able to go ahead? What is the next step, and what to order, and where to order, how to order? And if there is a roadmap is also given, and that will be a great thing. I'm glad that modern medicine is going to the greater level, and genomic studies are going to be the future, and we will be, unless this era is omics era, we say it is the era of omics, and everything we talk about genomics or proteomics or all these omics are going to become important area. So GPs has to also learn to know about entire billions of DNAs of our body and how they are going to act is going to be there. I perceive, and in the next 50 years or even 25 years, and no one will talk about the disease. It will be more of a cell and the tissue, or the centralized focused medicine only will be talking. And not only that, we'll be able to also offer. It is not only understanding the disease, we'll be able to offer a lot of treatment. Finally, I will say that whenever we talk about obesity, I always used to say we have different kinds of two-wheelers. One Hero Honda for 1 petrol, it runs 80 kilometers. We have a Bullet for the 1 liter, it goes only 20 kilometers. So it is not the liter, the petrol is the cost, but the carburetor or the emission which is there in the Bullet or the vehicle is the reason for how long it runs. So it is not that what we eat, but how our body metabolize it, how our body take it is the most important thing. And if you can get that knowledge and idea, then how it is going to serve, it will be a great benefit for that. In that area, GPs as a primary care contact, they have a tremendous role to play. So I'm so thankful once again, and wish and hope that this study is going, this lecture series is going to stimulate the Pandora's box on the genetics to be traveled and understood by the general practice. Thank you, Dr. Avinash, for this your initiation and wonderful work. So hope to wish to see a lot more things from you. Thank you.
Thank you, Dr. Jalal sir, for your enlightening words, and we are always look forward to you for this type of support and blessing. Thank you, and over to you to Genescope for the further lecture.
Okay, great. Yes. Thank you, Dr. Jalal. Your words were really encouraging, and I loved the last analogy, the analogy that you gave at the last. I think precisely summarizes how nutrients are metabolized differently in the body. Thank you very much for it. We will certainly pass on all the information on how a doctor or a practitioner can use this and how Genescope can help in providing this information. We'll certainly disseminate that information. And the next speaker for the day I'm going to introduce is Dr. Kedar Joshi, who's going to talk on a very important vital topic, and that is how genetics can be used in providing information on which drugs would be the right choice for a patient. So Dr. Kedar Joshi is a medical, he's a doctor. He comes from the educational background of MD pharmacology, Dr. Kedar Joshi is Medical Director at Resilient Cosmeceutical Private Limited, and he has been an advisor to us on pharmacology and many other medical aspects. We can also definitely consider him as the pioneer member who definitely helped get pharmacogenomics on its feet in the country at consumer genomic level. And I'm sure that the audience will definitely love what he's going to say over here. Okay, so over to you, Kedar sir. And we'll maneuver the slides from here. Please do let us know the next point. Thank you.
Right. Thank you, Dr. Amol, for that brief introduction. And I thank Dr. Bondwe sir and the IMA CGP for giving us opportunity to present this important, subject or topic in the field of medicine. Am I audible, Amol?
Yes, sir, you are audible. You are absolutely audible.
Okay, so I'll straight away move into the topic as such, which is pharmacogenomics. Over the period, we have been hearing about precision medicine and personal medicine. However, after the completion of Human Genome Project and the gene-wide association studies, or what they call it as GWAS, certain confirmatory results have come for the field of pharmacology from the genetic studies, and they have been now translated. They are no more into research. They are actually translated into the clinical practice, and many of the people are using it in their day-to-day practice. As it is said that it is, as it is called as precision medicine or personalized medicine, the name itself suggests that it is to be, designed for an individual. So, it started from Dr. Atul and Dr. Amol. They were talking about one fits all or not fitting all. That kind of approach we are adopting, and we are moving towards more of a personalized care and personalized drug treatment, to get better results and better efficacy and less toxicity, so that the overall management of the condition of the disease is optimized. Next slide, please. Hello, Dr. Amol. Anybody can change the next slide? Yes. So this is just an example which even Dr. Atul talked in his during his talk. I often wondered while moving out at the road, on the roads or at the signals or at the malls, why some human beings they behave like the apes, or of course apes we know that we call them as our ancestors, but why some of them are behaving like pigs at the signals or on the roads. The reason itself is very clear. The pigs have about 95% similarity in their genetic structure with the human beings, and the apes have about 99% similarity with the genomic structure with the human beings. The point I'm trying to highlight here is, that small percentage of change of 1% or 5% can make a huge difference. So from apes and pigs, we call ourselves as human beings with that small difference in the genomic structure. Next slide, please. This is another example of the same genome, but the different phenotypes. So the genetic material is the same. However, the phenotypes are different. The slide itself is quite explanatory, or it is self-explanatory that even human beings. Next slide, please. Even human beings can actually have different phenotypes based on their genetic makeup. So the terminologies that Dr. Atul and Dr. Amol were referring to, like SNP or single nucleotide polymorphism, that could be responsible for several differences amongst the human beings also. With the easiest example is probably the color of the eyes, or color of the skin, or the texture of the skin and texture of the hair. So these small differences in genetic material or genetic information can make such differences. However, we look at them as cosmetic differences. But if you apply the same logic to the internal physiology of the human beings, we find there will be certain differences amongst individuals when it comes to physiology. So every individual will respond differently, and based on its genetic makeup will respond to the drugs differently. Next slide, please. Sir William Osler, who is regarded as the father of modern medicine, who was a Canadian physician, who mentioned about variability, the variability that we see as a cosmetic factor in day-to-day life. He actually documented variability in his clinical practice with the statement, variability is the law of life, and as no two faces are the same, so no two bodies are alike, and no two individuals react alike and behave alike under the abnormal condition which we know as disease. So every individual itself is a different person, and the way he will react to the same disease will be different. So this variability, and this, though William Osler has documented it, you guys are seeing this in day-to-day practice with rampant variability amongst the disease profile, amongst the responses to the drugs. Next slide, please. So this is just a pictorial form of defining variability which is seen in day-to-day life. There are several conditions like mentioned, like depression, asthma, cardiac arrhythmias, diabetes, migraine, arthritis, osteoporosis, Alzheimer's, and cancers. Now, the happy mnemonics there, they suggest that they are responding to the treatment, whereas those who are not raising their hands, they respond to the ineffective treatment or having some issues or side effects. So in depression, about 38% of the patients will not respond as expected to the medication, and therefore psychiatrists or psychiatrists, they actually keep on giving the trials of different dosages so that the patient will different, not only dosages but even different drugs, so that the patient becomes goes into remission and remains there for longer time. So it is about 38% in depression, 40% in asthma, so on and so forth in cardiac, diabetes, migraine, and it goes up to 75% of the patient in cancer chemotherapy. They will not respond to the medication that is started of the empirically or as per the protocols. Therefore, it is from this slide it is evident that today pharmacogenomics has been adopted by psychiatrists and cancer to a very large extent in the clinical practice. Next slide, please. These are the examples of the drugs that we encounter commonly in the general practice or in a day-to-day practice. NSAIDs, we know that there are at least 10 groups of NSAIDs, and every individual responds differently to when it comes to even the choice of NSAID or a painkiller. Every layperson or individual will have its own choice. Like someone says that I respond to Combiflam, that is ibuprofen, more than the Voveron, that is diclofenac. So there always is a personal choice, and this personal choice, believe me, comes from trial and error, which gives you a better efficacy and less adverse effect profile. So on and so forth. There are drugs like codeine, tramadol, metformin, glibenclamide, pioglitazone. These are the drugs that we encounter on a daily basis. Tricyclic antidepressants, SSRIs. Today in geriatric medicine, there is increasing trend of writing escitalopram for different anxiety and depressive states in geriatrics. Escitalopram is definitely affected by the individual's CYP26 makeup, and based on the metabolism status, which I'll come to a little later, the individual will respond. Warfarin, clopidogrel. I'm highlighting this, and I'm having a different slide on this particular drug like warfarin, because we in pharmacology or in practice, clinical practice, we call this drug as a drug with narrow therapeutic index. So a slightest change in dosages, can alter either the effect or the adverse effect profile, which can be life-threatening. So warfarin, I have a different slide when I'll explain to that. However, because of its narrow therapeutic index, today the dosages of warfarin are, judged or given based on the clinical response that you get, and then INR or some clotting mechanisms that we check on a routine basis. Now there is a test or method by which you can actually guess an individual how he will respond to warfarin. So there are examples of statin, proton pump inhibitors, beta blockers, and S inhibitors, which will show a large amount of variation in efficacy and adverse effect profile. Next slide, please. So when we call pharmacogenetics, it is nothing but application of the genetic information to pharmacology. Pharmacology has basic two pillars, pharmacokinetics and pharmacodynamics. I'm definitely not going into details of that, but pharmacokinetics is brought about by absorption, distribution, metabolism, and excretion. And pharmacodynamic is actually the drug receptor, drug transporter, or drug enzyme interaction that will get the benefit, desired benefit, that is effect and or adverse effect. So kinetics and dynamics, which are two pillars, this science or these logics are brought to the effect by something called as metabolizing enzymes, of which we are very well versed with CYP450 enzyme system, which is primarily situated in the liver. Then there are some other enzymes and transporters which bring about the kinetics or the movement of the drug inside the body. And pharmacodynamics, again, receptor transporters and enzymes. The point I'm trying to make here is, all these things are nothing but proteins in nature. So whether it is metabolizing enzymes, whether they are transporters, whether they are CYP450 enzyme system, the receptors, the transporters or enzymes, they're all protein in nature. And for every protein, the genomic code has been there inside the individual's DNA. And when you check it, that if there is a slight difference, the person will have a different protein or a protein with different functionality, and it will definitely affect kinetics, dynamics, and therefore it will have impact on the drug response. Next, please. I'll not go much into details of this slide because it has been talked about by even Dr. Atul and Dr. Amol, that the point I'm trying to highlight here is the SNP. So there are three genes, one gene from three different persons, person 1, person 2, and person 3. On the right hand side, you will see a protein product, which is like a lily or a flower kind of structure. Now the first person is having a normal gene with a sequence of alanine, arginine, aspartame, so on and so forth. Whereas the second person has the same sequence of amino acids. However, in alanine, there is a change from GCA to GCG. So A to G, there is a change, but still the amino acid remains the same, that is alanine. So second person will have a similar protein in structure, but functionality might be different, may not be different, or may be different. Whereas in the third person, you will find that in place of arginine in the normal individual or a normal gene, it has been replaced by lysine in the third person. So a change in nucleotide, which was the sequence which was AGA coding for arginine in person 1, has become AAA, which codes for lysine, and then you will find that the structure of the protein is totally distorted or different, and so will be the functionality of this protein. Now, correlate this with the previous slide where I was talking to you about the metabolizing enzyme, the transporters, the receptors, they are all protein in nature. So a slight change in this genomic information, that is SNP or polymorphism, the resultant protein will change, and so the drug effect and the drug results will change. Next slide, please. So there are several polymorphisms or changes, one of which we call it as single nucleotide polymorphism, where 2 million SNPs are present in a human genome. However, they are not all harmful. Some of them are useful also. There are other polymorphisms where the entire gene is either inserted, additionally inserted, or deleted. So the person becomes, the genetic information is different. Now, if a gene coding for CYP2D6 in an individual is deleted completely, that means the enzyme 2D6 will not be formed, and the effect of that enzyme will not occur in the body. So as to say that this person will become a poor metabolizer. Then there could be gene duplication. So the entire gene becomes, duplicate, repeated again and again. So the same example, if I take, if it is a gene of 2D6 enzyme, if it is duplicated, more numbers of 2D6 will be produced. So the number will be high. So the function will be high, and the person becomes hypermetabolic or ultra rapid metabolizer. And it will churn out the drug or metabolize the drug faster, so that it will have no effect either, or it will have a very high effect if it's a true drug. So these are simple other polymorphisms apart from SNP that can happen in an individual. Next slide, please. Next, please. So I'm giving you an example of so many metabolizing enzymes in the body. Kinetics, in kinetics, you have phase 1 and phase 2 metabolism. All these enzymes are nothing but the protein molecules that bring about changes not only in drugs but even in the milieu interior or the normal physiology. They have a role to play, and any changes in these enzymes, genetic material in these enzymes, will definitely cause the resultant effect by altering the drug metabolism and its effect or adverse effect profile. Next, please. So as I said earlier, there could be 4 scenarios when it comes to the metabolizing enzymes. Let us take an example of CYP450, any enzyme for that matter. So if both the copies of genetic information, if both the copies of genes or the alleles of genes coming from your paternal side and maternal side, they are normal, the individual will have a normal 2D6 numbers as well as functionality. So these individuals, we call them as normal metabolizers, or the terminology in old days they used to use as extensive metabolizers, but nowadays we use the terminology as they are normal metabolizers. Now, if there is an issue with the 2D6 gene, there is a SNP, or the gene is entirely absent, the person becomes poor metabolizer. So the whatever amount of parent drug you ingest will not be metabolized. So the drug will have the accumulation in the plasma, and it will result into very high efficacy and high toxicity, and extended efficacy or the hyper efficacy. In such cases, we can call it as even toxicity also, because if warfarin has higher efficacy, that means it will actually lead to toxicity, because it will not get metabolized to the metabolites and will not be thrown away. Similarly, when there are gene duplications, the enzymes produced will be high in number as well as their efficacy will be very high. So they are called as ultra rapid metabolizers. So the drug that is taken, ingested, can get converted into metabolites so fast that it is without making any action, it gets converted into metabolites, and therefore it will not have any activity. Now the scenario changes when it comes to a prodrug like codeine or tramadol. Please remember, codeine and tramadol, both these drugs are prodrugs. So they get converted into an active metabolite, which will bring about its action. So codeine and tramadol, they get converted into a morphine derivative, and then it brings about the action. Now, in case of poor metabolizers, if codeine and tramadol are given, then there will not be any action seen, activity of this drug seen, and it is only the parent inactive drug that gets accumulated in the body. However, if the individual is an ultra rapid metabolizer, tramadol and codeine can get so rapidly converted into the active metabolite, that is morphine derivative, that it will bring about toxicity, and patient have died because of giving the normal dosages of tramadol according to the individuals with ultra rapid metabolizer status. So that is the impact of checking an individual for its metabolizing status. Next slide, please. Now, this is just to understand what I said right now in a textual form. This is a typical plasma concentration versus time profile of nortriptyline when given in 25 milligram dose. Nortriptyline is extensively metabolized by CYP2D6 enzyme system. Now, the plasma concentration curve, the topmost plasma concentration curve, if you see, there is presence of zero functional 2D6 genes. That means this individual has got no 2D6, active 2D6 manufactured inside his body because that gene is not functional. So this individual is labeled as a poor metabolizer, and you can see the concentration of plasma vis-a-vis a person having a normal metabolizing status, which is denoted as number of functional 2D6 genes as 2. So 2 normal functional genes having individual, compare that plasma concentration versus this individual, and you'll find it is about double the concentration that is achieved. Not only the peak plasma concentration, but the 72-hour, the end concentration also is almost double. Now, if this individual is kept on dosing repeatedly, the drug is going to get accumulated and this concentration curve is going to rise upwards and will definitely cause adverse effect. And nortriptyline is known to cause adverse effect related to cardiac system or the arrhythmias. The person which is at the bottom, which is showing that it has 13 functional CYP2D6 genes. Now, this individual is absolutely not showing plasma concentration that is detectable. So because of that 13 functional genes, the number of 2D6 enzymes are so high and so functional that nortriptyline, which is given in the dosages of 25 milligram, will be rapidly metabolized and the individual will not have any effect. So that is the impact of labeling a person whether he is a poor metabolizer or ultra rapid metabolizer. Next slide, please. Now here, it's a different example, that is metoprolol, which is you can see on different pharmacokinetic parameters like Cmax, AUC, T-half, and clearance. What you will see in ultra rapid metabolizers and poor metabolizers, because metoprolol is also metabolized by CYP2D6 enzyme system. Metoprolol is another very commonly used drug, and it will have so many effects because of the metabolizing status that you usually do this, conclude the effective dosing based on the trial and error method or titration, upward or downward titration for that individual. But with the test, you can initiate the therapy with proper dosages or the range of dosages. Next, please. Here, there is an example of AUC, plasma concentration of pioglitazone and metformin. Within male and female, gender-wise also, it shows a large variation. But if you look at the concentration ranges for males or for females, it differs from 2,000 to 10,000 in males for pioglitazone, and from 2,000 to about 14,000 for males in metformin concentration. So based on the genetic profile, individuals show this kind of differences in plasma concentrations, and that definitely is going to affect the efficacy and adverse effect profile. Next, please. Just to enumerate, if an individual is given 100 milligram of dose, today's practice is when you look at the prescribing information, the entire group of patients, you start with 100 milligram dosages. So before this kind of judgment or test was available, it was fit for all approach where 100 milligram of dosage was given to all the population, irrespective of gender also and the metabolizer status. Now, having labeled these individuals or grouped them into different metabolizing status like poor metabolizers, intermediate, extensive or normal, and ultra rapid, the dosages can be so different in these individuals that extensive or normal or intermediate metabolizers may respond to 100 milligram better, whereas poor metabolizers will respond to 10 milligram, and ultra rapid will require about 500 milligrams to be given to get that desired function of a drug. Next, please. So today, so far I was talking to you about the plasma concentration versus the action. Metformin is a classical example where pharmacokinetic as well as pharmacodynamic parameters both can be judged with a genetic test. Now, metformin, there are actually 20% of the population, diabetic population, which is a primary non-responders to metformin, even on the clinical grounds. So if you start an individual on metformin, 80% will respond, but 20% will not respond to metformin. However, this fact is so neglected because actually most of the times metformin is started with some sulfonylurea or some other anti-oral hypoglycemic agent. So the efficacy is not attributed to an individual drug, whereas it is attributed to the combination. For metformin, it doesn't get metabolized in the body. It circulates in the body in the form of intact compound, parent compound, and it is transported throughout the body with the transporters, with the help of transporters. What we call them as SLC or solute carrier family transporters. So from the intestines, when you ingest metformin from intestines, it is carried into the central circulation or plasma by a transporter called as SLC 22A1. And this 22A1 gets in the metformin into plasma. Further, by A1 and A3, it is taken into the site of action, that is the hepatic cells. In the hepatic cells, as we know that metformin's primary pharmacological action is inhibition of gluconeogenesis, that is generation of blood sugar, generation of glucose from the non-carbohydrate sources, that is fats and muscles, primarily fat. This is brought about by a gene called as ATM gene. So metformin actually acts through this gene so as to inhibit the gluconeogenesis. Now, if this gene is defective, then metformin will not act. Now, in certain individuals, this gene is found to be defective, and metformin's action will not be the major action, I am saying. However, in a small percentage, you might get the activity of metformin as insulin, increasing insulin sensitivity of the peripheral cells, etc. But the majority of its action will be blocked because ATM gene is non-responding to metformin action. Similarly, from body, it will be thrown out into renal system, or through urine it is excreted as intact drug through the transporters. Now, these transporters also may have issues because they are proteins in nature, and their genetic coding will define whether this transporter will be functional or not. So if 22A1 transporter is, say, non-functional for that matter, metformin will not get effectively absorbed in the body. It will remain in the intestine, and these individuals will show the adverse effects, which are local adverse effects of metformin, that is diarrhea. So if higher concentration of metformin is seen in plasma, it can lead into headache and nausea, or even lactic acidosis in some individuals. So this is a classical case of application of genetic knowledge or pharmacogenetics to pharmacokinetics as well as pharmacodynamics. Next, please. This is another very important drug which I touched upon in the earlier slides, that is warfarin. Warfarin acts through an enzyme called as VKORC. So vitamin K oxidoreductase enzyme, which is responsible for activation of vitamin K into its oxidized state, so that or oxidized vitamin K actually is converted into reduced form, that is reduced vitamin K or K1, which further gets converted into reduction, and then it will actually trigger the clotting cascade, that is the factors, different factors like F7, F2, so on and so forth. So vitamin K reduction is actually brought about by, it is inhibited by warfarin. Now, if there is a mutation in VKORC gene, then warfarin will not be active. Warfarin will not be able to convert the clotting factors from its inactive state to active state. Therefore, you will not have activity of warfarin, which was desired as a blood thinner or anticoagulant. Warfarin also is metabolized by an enzyme called as CYP2C9. Now, if you have, and it is converted into an inactive metabolite as 7-hydroxy warfarin. So warfarin's metabolism, if this 2C9 is defective, then an individual, if he is an ultra rapid metabolizer, again you will not have activity of warfarin. But if he is a poor metabolizer, then you will have higher concentrations of warfarin, and it may lead to the higher inhibition of VKORC, and then you will not get the effect. Instead, you will get the extended or the higher hyper pharmacological action, which will lead to toxicity. So this is another pharmacokinetic pharmacodynamic application example. Next, please. Similarly, so on and so forth. I can go on and on, but beta receptors, as I mentioned about metoprolol, it acts through beta receptors. Beta receptors bring about the changes in the G protein coupled system, which brings about changes in adenyl cyclase and calcium, intracellular calcium, so as to bring about the concentration of the muscle, cardiac muscle. So if this beta receptor is altered, because it is a receptor, it is a protein, and the genetic information will decide whether this is an active receptor or not. So metoprolol will not be coupled with beta receptor, so the norepinephrine can act freely, and it will continue its action, and the desired action of blocking norepinephrine effect will not be seen. So these are the kind of applications of pharmacogenomic testing which can be brought into clinical practice. Next, please. Similarly, angiotensin converting enzyme inhibitors and ARBs, they're all receptor, they're all proteins, and their functionality is based on functional gene, or whether the gene, there is a SNP present or there is a polymorphism. Next, please. So pharmacogenomics, or PGX, it is genetic variation. To summarize the role of pharmacogenetics or genomics, genetic variation plays a role in variability of drug effects in patients. The application goes beyond actually labeling an individual with PM, IM, normal metabolizer status, or only PK, but it can go up to identifying a person whether he has a functional receptor or functional drug enzyme or not. So it can actually bring about the changes in the drug receptor action, as well as the interactions also. So it is the science that allows us to predict response to drugs based on individuals' genetic makeup. Next, please. As of today, as both the speakers before me, they mentioned that this is an ongoing science, and every day new information is being poured into, and it is coming into clinical practice. As of today, there are close to about 200 drugs which carry pharmacogenetic information in their on their prescribing information. So US FDA has made it mandatory to incorporate this information into the prescribing information. As you can see, this pie chart shows that most of the drugs from oncology and hematology sector, the PGX is applicable, whereas followed by psychiatry, infectious disease, so on and so forth. So there are many drugs from many different, specialties. However, the biggest application of this is seen in oncology and psychiatry. Infections and cardiology, rheumatology, yes, there are tests available which can be employed in the clinical practice because they are now into the so-called as actionable information, and it is in the prescribing information. Next, please. I'll skip this one because this is just shows with an example like with 2C19 CYP enzyme, which actually brings about the metabolism of omeprazole. What kind of dosages that can be titrated as for the intermediate metabolizers, poor metabolizers, or ultra-rapid metabolizers. So omeprazole for intermediate metabolizers or normal metabolizers, intermediate metabolizers and poor metabolizers, the dose has to be decreased. Ultra-rapid metabolizers, the dose has to be increased. It doesn't actually, stop there because higher concentration of omeprazole or proton pump inhibitors, even given as a single dose, can damage renal system. So nowadays there is a warning on PPIs that it can cause renal damage, and this information is definitely clinically applicable, as if you keep on dosing the individual and the concentration is high, then it will not only seen as efficacious or non-efficacious or having adverse effect profile, but it can actually cause some damages in the body. Next, please. So similar examples of different drugs like irbesartan, celecoxib, phenytoin, and warfarin. Next, please. Next slide, please. Yeah. So as I said, applications of PGX today are majoritarily seen in oncology with methotrexate, gefitinib. These are some of the examples of drugs that needs to be tested for PGX profile. 5-fluorouracil, imatinib, irinotecan, platins. The question here is not to only find out the efficacy of the drugs. Of course, it is very important because we are treating a condition like cancer, but the focus has to be there on reducing the adverse effect profile and whether the drug is active for that particular individual in that particular cancer. To find out that is extremely important, because believe me, these drugs do not come at cheaper cost, especially like gefitinib and imatinib kind of drugs. So oncology, the larger proportion of drugs today are checked for PGX profile, and then they are employed. In psychopharmacology or in antipsychiatric or in the psychiatry segment, the tricyclic antidepressant, SSRIs, and antipsychotics, they are all tested for PGX because there is no objective marker for looking at the diagnosis and prognosis of psychiatric conditions. There is no lab test which can say like blood sugar level or BP, which can say that there is an effect of the drug. So it is all more of subjective, though there is a lot of objectivity brought about by different scales in the practice to find out the exact, and therefore you will find that, and these drugs like tricyclic antidepressants and SSRIs, they take longer time to stabilize on their plasma concentration profile, and so to bring about the remission in an individual. So if you have that information before you start the therapy in hand for that individual, not only which drug or which group of drugs can be started, the dosage ranges that can be employed. So it has come to that level in psychiatry segment. Next slide, please. The other applications like in cardiovascular diseases, statin, warfarin, clopidogrel, beta blockers, antihypertensive, antidiabetics, you name it, and there is a drug which has an application in PGX. So I talked about those 200 drugs which are now mandatory by FDA to be looked into from the pharmacogenetic profile. Many of them are belonging to this anti-hypertensive, anti-diabetic segment. So pharmacogenomics actually not only tells you drug disposition, but it also tells you about the drug targets and even side effect profile. Extending it further, it can actually tell you even about the drug interactions, which is a very important problem in a day-to-day practice. Next, please. There is a huge application in infertility and treating PCOS cases, whether the FSH, LH, other hormones, the drugs like metformin, drugs like estrogen to be given or not. There is a test in PGX which actually tells you about whether that individual lady should be put on the oral contraceptive pills or not. Now, this is a very interesting question I'm throwing to the audience. It is so rampantly used. The OC pills are so rampantly used as birth control measures, as well as for the treatment of PCOS, etc. We often forget or neglect the rare but serious adverse effect profile of OC pills, and that is pulmonary thromboembolism, or the deep thromboembolism, or episodes of thromboembolism, which can be DVT, which can be pulmonary embolism. Now, with a simple genetic test, we can identify an individual who is prone to have thromboembolic episodes if she receives the oral contraceptive pills. So that is about infertility and PCOS. Next slide, please. So pharmacogenomics or PGX, it helps draft precision protocols and personalize the treatment. It reduces trial and error. Prediction of efficacy and safety is easy if we employ PGX testing. And there is a pharmacoeconomic angle to this also. Now, as a practitioners, we often overlook this area of pharmacoeconomics. For example, when 7 years back, when we took this metformin test to the physicians, some of them came up with an excuse, I would say, that they said that Dr. Joshi, metformin is costing less than a rupee. It has an excellent safety profile because very rare adverse effects are seen in individuals. So why do this kind of costly test for that individual? Now, it doesn't stop there. Now, morally or ethically, when we look at it, if a drug is not having any activity, why we should be prescribing it? That is first. Second is accumulation of metformin. You're exposing that person to lactic acidosis if the person is consuming alcohol, and sometimes he tend to binge on that, and then he may land up into the adverse effect like lactic acidosis. And moreover, look at the number of days, months, and years he will be taking metformin without any effect. So the economics stands there. So 1 rupee per day, if he's taking for 20 years, just imagine how much impact it will have. In fact, you can actually give him a better drug than metformin by doing this test. Next, please. Now, this is not our research. This is not the research which we have done. The research is done world over, and there are two leaders in this. One body is called as PharmGKB, and the other is called as Pharmacogenomic Research Network, which is an initiative by the NIH USA. These two bodies came together, and they started looking into the evidence which is generated world over, and they brought those that data. They collated those evidences, and then they formulated the guidelines for implementation of pharmacogenetics, which is called as Clinical Pharmacogenetic Implementation Consortium Guidelines. Now, this CPIC, they all have their own websites, and you will find the guidelines present on this CPIC website. So this is not our own, our individual research, the research done by our company, but it is actually, world over it is done. Precision medicine is a division of FDA, US FDA, which is looking independently from NIH into this, and they are making it mandatory for the pharma giants or pharma sponsors to add this information into prescribing information. Then there is a Dutch group, there is a Canadian group, and of course Mayo Clinic, which are very, very active for the last decade or so in pharmacogenomics. So it is entirely an evidence-based medicine and evidence-based guidelines, which are now ready or which are now employed in clinical practice. Next, please. So Hippocrates has said it is more important to know what sort of person has a disease than to know what sort of disease a person has. So whether you are employing nutrigenomics or the pharmacogenomics, you are trying to find out what sort of person you are treating rather than what sort of disease the person is having. Next, please. Again, I would like to quote Dr. William Osler. He always said that the good physician treats the disease, the great physician treats the patient who has the disease. Next, please. So with this, I would like to thank you all for your patient listening. I once again thank the organizers, Dr. Gondwe, IMA CGP, for giving me opportunity to present this interesting topic of pharmacogenomics. If time permits, we can have discussion, question and answers. Thank you so much.
Thank you, Dr. Kedar. Hello, just a moment. There's a glitch.
There is one question from our dean, it seems.
Yeah, can you hear me?
Does this pharmacogenomics affect the effect of vaccine? Very reasonable question.
Dr. Kedar, I think the question is for you. Is pharmacogenomics, is there any connection with the vaccine? So, sir, could you please repeat the question? I think we...
Yeah, I was not audible actually.
Sir, it is a question from the chat box, sir. Our dean has asked it. Does the pharmacogenomics affect the effect of vaccine?
It's a very interesting question. You go by science and you will see that yes, it definitely affects because the entire concept of giving vaccine is to generate an immune response in an individual, and this immune response is based on all proteomics. So it is all based on proteins. So whether you are talking about the COVID vaccine with mRNA, or whether you are talking about the spike protein vaccine, you are injecting a protein inside the body against which your body is trying to make up antibodies, or you are training your body to make those antibodies. So as a science, yes, there is a room to say that it will affect, and it is evident from the fact that there is so much variation in the immunogenicity of an individual and the protection that he gets from after getting the vaccine. However, today there are no tests such available to evaluate such claims.
Okay,
thank you.
One question to Dr. Amal.
Yes, sir.
What are the genomic tests available for NCDs and the cost pertaining to it?
Okay, so the common NCDs such as obesity, type 2 diabetes, followed by that PCOD, then syndromes such as gastric distress or overall cardiovascular vascular diseases. There are genomic tests or nutrigenomic tests available which will look into the genes associated with these. Okay. Followed by that, in certain cases, we have seen that when individuals suffer from more than one such kind of conditions, overall health profile is better, which will look into multiple genes that could be interconnected. So while there are tests available for such multiple lifestyle diseases, usually we have seen our experiences that we end up recommending something called as a health profile, which looks into most of the metabolic genes. So hence we have two categories of tests, focus test as well as the comprehensive test, which is health panel.
Range.
Now, the weight loss is an important topic. Hence, we have a separate test for weight loss because the number of genes that contribute for weight loss in terms of intervention are more. Hence, we can see that there are three categories of tests: the focus test for different diseases, health profile for combined this thing, and the third is the weight loss genetic test. These are the three. Now, in terms of range, the range varies from 4,000 rupees up to 16,000 rupees. This is the range of the test price, which will usually include the nutrigenomic test. It will include the diet and exercise consultation, hand holding for a period of 2 to 3 months, because that is what is essential. Only delivering a report, people, a common man may not be equipped to understand it. So the price range will range from 4,000 to 16,000, including the test plus the hand holding period for 2 to 3 months.
I would like to add something to this actually, Amu.
Yes, sir.
To answer this question, I think you have a panel, right? There is a panel which can be customized as per the individual's needs, if I'm not wrong.
Yes, sir. We also have panel. So when it comes to condition, like when, let's say, for example, an individual has signs and symptoms which do not fall typically in category of a particular condition, or it's a combination, we usually will pick up a couple of genes and then combine it together. For example, let's say, for example, we understand that a person is suffering from inflammation, oxidative stress in this condition, and looking into all other genes are not required, then only such genes will be tested. This is where the pre-test counseling comes into picture, where whether a single panel is needed, a customized panel is needed, or a comprehensive panel is needed is taken care of.
I'll add one more thing to this actually. See, if a person is having problems with lipids or cholesterol issues, then there is a test called as ApoE test. Okay, now ApoE test actually can define an individual in certain categories. Now the blanket advice to these individuals today by dietitians is to have omega-3, omega-6 or omega-3 fatty acids like fish oils, which will bring about those cholesterol changes or changes in triglycerides. However, based on this ApoE test, in some individuals, actually it can have exactly opposite effect. So if a person is having ApoE3, E4 profile, then giving him omega-3 fatty acids will actually have a deleterious effect and it will increase the cholesterol. So these individuals, instead of going through a blanket advice, we advise these individuals to go for the test and then check for the diet. At the same time, this test actually defines whether the statins are working in these individuals or not, if they are working at what level. So that is how the application goes. So it depends on the problem that individual having. We can have a customized solution and we can have the entire panel also to be employed for that.
So both customized as well as individualized panels we have to create depending upon the nature of their compliance and their family and then personal history.
Right, sir.
Everything that includes in that, sir. We understand, sir. Then where are the centers which are available in India where we can do this kind of tests, sir? Any idea about it, sir?
Yeah, so so in terms of the centers, the sample, there are two touch points for which we need connect with the individuals to go ahead. One is the sample collection and the second is the consultation or the advice. The sample collection is saliva or blood, for which we have either a home collection mechanism for saliva, because it can be done by a person on his home and at his home on his own. And what we do is we will ship a saliva kit which can be used by a person to provide saliva. So that entire logistics is taken care. The second is if a blood sample is required, in such cases, we do have connects and collection centers across the country, and blood collection also can be arranged. The third is the counseling part. Most of our or majority of our consults, we are Pune-based organization. So majority of our consults are over the phone or Skype or telecom. So this is how the mechanism has been. So in terms of geography, I think as I mentioned, the number of tests we have done somewhere around 18,000 plus. All these 90% or more of them have been outside Pune, where the mechanism has been getting the sample from the other place to Pune and doing consults over the phone. Dr. Atul would want to add a couple of points here.
Hello.
Atul?
Just to answer your question, Dr. Anburajan, we also would have a map on our website. And the reason why the email and the WhatsApp numbers been mentioned, if anybody has queries, so we are established, but we are evolving at the same time. And we will have a pan-national presence where we can actually connect with all the doctors in terms of the logistics and the SOPs for their specific patients. At this point in time, our website will be quite informative in terms of what's to be done. But if you have any specific questions, technical or related to logistics or guidance or tele, please do email us or WhatsApp us on those numbers which are given in the next slide. So we can give you a more detailed answer for your questions.
So there is possibility that even a patient from Tamil Nadu can get that tested through your center.
Yes, I mean it is not a big deal because we do have clients from Tamil Nadu, Mizoram, Delhi, all over the place. So we do have a connect because we do have courier services and outside India. I mean we have clients from South Africa and America as well. So Tamil Nadu is not too far away. Yeah.
Okay. Very good, sir.
So we do have a sample collection system in place. So let's say if you have a patient, if you call us, we can have it picked up and delivered. The advantage being also with our saliva collection kit, we have filed for a patent for a preservative or a buffer. So when the saliva is collected, the buffer is added to this particular saliva kit. Like you have these EDT and whatever samples, blood samples, which preserves the DNA for a very long time. So at room temperature, the sample can be, the shelf life is pretty long. Plus it has got an anti-COVID function so that when it comes to the lab, even the lab guys are pretty safe to handle that sample. So it's a good buffer that we supply along with the kit. So it's not any kit that you can use. We do supply our own kits, which can be used by respective doctors or people respectively.
Dr. Atul Gadakar, sir, what I would suggest that for the benefit of our delegates and IMA CGP members, if you send us a small video clip, how the sample is collected, in what way it is preserved, what type of rather the containers are and other things, along with the information of where to send, we can definitely put it on our IMA CGP website. So most of our members may benefit.
Thank you so much. That's a great suggestion. Yeah,
more of transportation also. More of transportation, which is.
Yeah, you can go to the next speaker.
Then some few words about gene therapy, sir. For some diseases, they have started doing gene therapy. CMC Vellore has started on gene therapy for hemophilia A. So, few words about that, sir. Which are the diseases now feasible to have?
Okay, there's a lot of work going on. There are a lot of therapies which are being evolved, but there are only a few which are FDA approved at this point in time. I will actually let Dr. Amol take charge and probably explain at this point in time, or we can even write to you. I mean, at a clinical trial level, there's a lot going on. There are only few, for example, slow moving disorders, or probably some RESQ9, which is like a micro deletions in blindness, or there is very little. We haven't really got ourselves involved in the therapy part yet because it's still at a clinical trial level at this point in time. But certainly therapy is what is going to be part of this entire journey, maybe in the next couple of years, definitely. It's not too far away for therapy to evolve. But having said that, Dr. Kedar Joshi is therapy at this point in time because pharmacogenomics in terms of therapy is a big thing that is going on. Although even there, the scope is pretty huge, because if you have like 100,000 drugs, maybe only a couple of hundred drugs are FDA approved. So there's a big scope there as well. But at this point in time, I think I'll let Dr. Kedar Joshi maybe say a couple of words in terms of therapy, because he's in the most apt position to say anything about therapy.
Yeah. So this gene therapy, we have been hearing. I mean, we had a one-page chapter in Goodman and Gilman when I passed out in 95, 96 from Biomedical College. Now it has evolved at a very high level. In fact, the way the vaccines are manufactured today, if you look at them, that is nothing but going through a gene therapy only. You know, the alteration of those genes or alteration in those proteins, and then making the individual to produce those kind of proteins. However, the application of gene therapy is at much higher level, and most of the things today are in research phase. There are some treatments those are available as proprietary or branded by some big multinational companies, pharma or the genetic engineering companies. These treatments are targeted towards sickle cell anemia, towards myeloma, multiple myeloma, and majority of them are right now directed towards cancer, because cancer is supposed to be the major killer after the road accidents in the next few years. Also, it will remain at that position. These therapies are exorbitantly costly at this time, and they are not in the reach of even in the higher strata also cannot afford that kind of therapy. So yes, there are about 10 different diseases, just like I mentioned, sickle cell anemia, multiple myeloma, and some of the genetic disorders, they can be treated, where an altered gene is actually injected in an individual, or it is engineered into an individual, and then it brings about those changes. So that is all about right now what we have in the gene therapy.
Thank you, Dr. Joshi. All the presenters had a very good applause from one of the attendee. Very brilliant session. So thank you all very much. One more question from one of our member. In corona, AC receptors are important. Can genomic tests be done?
Yes, actually, yeah, I mean, it's a very valid question. In the last couple of years, a lot of attention has been given onto this angiotensin converting enzyme, that is 2 ACE2 receptor, which is responsible for the entry of the virus into the white cells of an individual. A large amount of research has been done on that, and there are findings on the alteration in ACE receptors, where a person can be predicted as having affinity towards harboring the virus more inside this cell. However, these are all discrete studies done in different pockets. It started with China, then it migrated to US, everywhere. In fact, in the start of the pandemic in 2020, we had given a proposal to ICMR to, we had written it in association with Biomedical College, and we had submitted this proposal to, identify the mutation that is there in the ACE2 receptor, which can actually judge a person whether he is susceptible for more viremia or more severe form of disease, or he can actually acquire the infection, because there are so many individuals we have seen which do not acquire this infection. However, this proposal was rejected by ICMR because their priorities were quite different that time. Total focus was on the prevention and treatment. And in 2020, the kind of trial and error that has gone through, starting with ivermectin and azithromycin and doxycycline and everything, which turned out to be hawks later. We as pharmacologists, we always had taken a stance that will not allow hydroxychloroquine to be written, will not allow. Even I have suggested many of the doctors, many of the physicians, my colleagues, that please do not write these products, because they do not have efficacy, and what they will do is they will have the adverse effect profile. However, that turned out to be true 2 years down the line. But ACE2 receptors, yes, that time ICMR was more focused on the treatment. There is no large sample size study which has been done in ACE2 receptors. But looking at the pathogenicity of the virus inside the body, there is ample of opportunity to work on this and to find out who are susceptible to catch the virus.
Thank you, Dr. Joshi, Dr. Amol, and Dr. Atul, for you have done your level best to make us understand the very recent, fast-growing, branch of our medicine. And our Secretary General had a talk with me today that this nutritional genomics, that you will be invited, Dr. Amol will be invited for a another meeting in food safety very soon to
Thank you very much.
to our IMA doctors who are members of IMA through the food safety committee for the benefit of our members, sir. Thank you, sir. Now over to our Dean for a closure talk, sir.
Thank you very much. Glad to hear that invitation. We'll certainly be happy to be a part and discuss this at a much more bigger level.
Okay.
Is there one lecture remaining still?
No, sir. We are done with the speakers for the day.
So, thank you very much. And it was really a different experience in today's this CME. That we came to know so many novel things, so many things which rather were just the words to us were defined very well in this today's program. Initially, Dr. Atul Gadakkar, who explained all about what is DNA, what is genes and chromosomes with all its structure, clear our all the doubts, the importance of genomics, its applications, then the basic concepts of nutrigenomics, and of course all the other things regarding the very important thing that he told about that these genes and all the genomes are in the nucleus of the cell, and there are 46,000 chromosomes in our body and 2 million DNA and 3 billion subunits which are A, T, C, G, and about 25,000 genes are they create protein and all. So all this information was really very important in our rather understanding the medicine and the diseases in the medicine, because the genomics, as you people told, that it is for better diagnosis and better progress, and of course the optimized treatment and of all the effective clinical trials, as well as the disease monitoring, which is very, very important for all the clinicians. And in the nutrigenomics, Dr. Amol Raut explained it extremely well about the health and food and its relation. Of course, all the nutrigenomics and nutrigenetics concepts, and of course the hidden gene variation, which may produce the chronic disease. That was the main important thing I think we understood. Then about the prevention through the early intervention of this genetic diagnosis and treatment, genomic diagnosis and treatment, and all the other things about the food, exercise, and prevention of obesity, and what type of exercise you should do, and in what at what time, and everything was explained very nicely. At the end, Dr. Kedar Joshi, who explained about the pharmacogenomics, which was rather a very heavy topic for us, but being a pharmacologist and very, I must say, these people know the details and the principles of their subject. So they explained it extremely well about the difference between the pharmacogenetics, pharmacokinetics, and pharmacodynamics, in which are rather the other two terms we know, but we came to know about the pharmacogenetics. And of course, the sequence variation in gene can change the proteins produced by the genetic code. That was the principle of his speech. And about all the dosage variation and the prescribing information about these PGX drugs, all the things were very well understood and very well explained. And we are really thankful to all these dynamic and we may say the very knowledgeable faculties of today, Mr. Kedar Joshi, Mohd Raut, and of course Dr. Atul Gadakkar, who took pains to rather create today's CME, and that is really, really very effective. And I'm sure that we will be able to communicate with you whenever we have some problem. I appeal all our IMA CGP members to attend these type of CMEs, and of course, it is not once you attain the CME, that is not the end part of it. The only thing which rather Dr. Jayalal suggested, that you send us the way these things are done, and all these things. Just we mentioned that how to collect the sample, what are the indications in which now that in which we can use these principles of genomics, and all these things. I think if you send us a good article, we can definitely publish in our monthly journal, which is rather given to all the members of IMA CGP. So that is a really good thing. I congratulate again you all, and of course thank all our office bearers. And over to you, Dr. Amburajan, sir.
Thank you, our Dean, for giving an overall and concluding remark. And now we are towards the end of the session. Of course, two more questions are there in the question box that will be sent to our resource persons, and answers will be reaching you through mail. Okay.
If at all there are still in some questions, we have 30 minutes with us. We have announced up to 2 o'clock. So definitely, if anybody has any question, they can raise their hand, and you can definitely pass on. They can put their question in the chat box, and definitely, Dr. Amburajan, sir, you can ask these questions.
Yeah, and also just a quick interruption in what you're saying. Thank you, Dr. Avinash Bondwe. What you rightly said was, yes, we have a long way to go as doctors in this country. I will just give you a comparative note on, in America, maybe 14 million tests have already been carried out. And being carried out in millions on a yearly basis. So we are lagging far behind in this field of science. So collectively, we have to use this information. And for this information, we are in quite a position. This is a fantastic platform. We can conduct a few more CMEs if needed. If any specific topics or whatever you have in mind, whether it is in terms of any specific NCDs, if it is in terms of therapy, pharmacogenomics, etc., we are definitely willing to lend our time and support this movement collectively as a team of doctors, as I said, health soldiers for this country. We should certainly work towards public health using genomics. So,
Rekha is asking, since the test is once in lifetime, is it advisable for doctors to undergo? How do you advise?
Well, Actually, everybody on this planet needs to get this test done. Like I said, we do our pictures like when we are in a baby. So knowing ourselves is a very important aspect. It really helps us plan our life journey in the best manner. However, if technically, basically, this entire field in terms of nutrigenomics is driven by Dr. Amol. I would like him to share a couple of words in terms of, for all the doctors, how this test can be incorporated. We can have a plan set up.
Yeah, that would be a great opportunity. We can certainly, we would first love to interact with all those who are interested one-on-one, so that at individual level, what are the concerns, which health concerns, and how the test can help. We would love to do that. This, I think, would also be a good opportunity to experience something called as pre-test counseling. So what is the pre-test counseling, how it helps, and so on. So we have already shared our contact details. We'll further share it, but all the members over here and those who probably couldn't join, we all personally would love to interact and conduct the pre-test counseling. So I think that's a good way to go ahead, sir. That would be a wonderful thing.
And one more question from one of our members is, what is the role of genomics?
One suggestion I would like to give it to the Genescope faculty, that see, many a times it is seen that in India the doctors do not go for research, especially the clinical research. All of our family physicians have a lot of data, tremendous data we have. Only thing, we never go through it and analyze it. And IMA CGP always promotes this type of clinical research, and in which if the Genescope can have some study which may be spread to all our members all over India, that we can participate in this thing. Because if you see the research by general practitioners is very, very important. If you remember, the first largest study on diabetes, UKPDS, was conducted by the general practitioners or the family physicians in UK. And recently, the Omicron, which was evolved in South Africa, was also rather observed and treated, and all the clinical things were collected by the general practitioners and family physicians in South Africa. So why not India? So this type of thing we are definitely will be willing to do. And it's really, if you find something, we can discuss with our team, and we can definitely do this type of work. That will be really a fruitful part of today's these interactions.
Yes, Dr. Our Dean, that should be an area that we have to concentrate on for the future activities. We agree, sir. So one more question from one of our member. What's the role of genomics in CJD or prion disease in knowing the susceptibility of an individual, diagnosis and treatment? So it's common like in either.
Actually, never expected this question, because there are names and conditions that actually we did not learn during the 10 years of our medical curriculum, and then they suddenly start cropping up. Of course, there are few new advances also, recent advances also, but I mean, as a pharmacologist, as a scientist, having some knowledge in genetics or genomics, I would say that there will be a role for every, there will be a role of genetics in every individual disease or profile which is affected by, this kind of response or the pathology or pathophysiology. CJD is typically, if you ask me, it's a different name given to Alzheimer's disease, probably. It's a neurodegenerative disease. However, the pathophysiology in Alzheimer's is different. The protein that gets settled down in the CNS in Alzheimer's is different, and then the protein that is intracellular in this CGD is prion, which is intracellular protein, is different. However, then when it comes to proteins, its manufacturing and its functionality is all coded in your genetics or the DNA or gene. So there will be a role. Right now, they are just exploring out under gene therapy such different rare diseases like sickle cell anemia, hemophilia, multiple myelomas, even CGD, Alzheimer's. They are exploring the roles of how the gene can be altered, how that protein can be nullified. Because for that neurodegenerative process, that prion protein, which is intracellular, is very important. And scientifically, if you ask me, yes, there will be a role. When you find out the exact cause or the exact problem where it lies in the gene, because sometimes it is not only the genes that is to be blamed. It is their precursors, or some call them as, Amul will be right person to talk about it, that promoter regions and the other regions in the DNA. Those actually, kind of switch on and switch off these genes, and their expression is based on these promoter regions. So there could be a problem with that. There could be a problem with genetics. So the gene itself. So if they know exactly why prion is getting precipitated in the CNS or the cells inside the CNS, then there will be a role. There will be for sure role a few years down the line. So right now it is just supportive care and ambulatory care that is to be provided to these patients. But work is going on these lines. Yes.
Thank you. Thank you, sir. Thank you, Dr. Joshi. So now we are towards the end of this program today, and this is a beginning only. IMA and CGP will be traveling with you for the, in the future along. As a customary, we are now going to the vote of thanks session. We have to thank our national president and also our honorary secretary general for allowing us to have this kind of programs very often for the benefit of the general practitioners, primary care physicians in India. And we also appreciate their presence whenever we call them for these meetings to preside or give their, guidance. And our dean, Dr. Avinash Bande, is a very enthusiastic person, have knowledge a lot regarding the general practice and enthusiasm to carry about the knowledge dissemination among our members is of very much appreciable. And our team, the Vice President, John Janmajaya sir, and our honorary secretary, Dr. Anbarasu, and other joint secretaries, Dr. Rekha, Dr. Prabhat Kumar, Dr. Jayan Sharma, Dr. Sanjay, Dr. Bora. There are all persons who are having a lot of, support for the activities of CGP that is continuing. So our special thanks to Genescope that you have made our eyes opened in a very important area of our medical science. Dr. Adul and Dr. Amol and Dr. Joshi. So three of you have done your area of that vicinity in a very good way, and you have been very patient in giving us, explaining things coming to our level and make us known the facts, and also very patiently, hearing our questions and answering them in a very feasible way. So once again, you can show your contact details. My request to all the attendees that for your any doubts or any clarity about this further, you can very well see our website, as well as you can contact the Genescope very well to get cleared about your, doubts. And in future, we are going to have a lot of such programs. And as mentioned by our dean, we'll be having collaborating for research programs with our general practitioners who are the primary care physicians in India. Once again, we thank, I think, the person who has hosted this, Deepan, who had done it very well, though we had a little problem, but he was able to manage everything and then make it feasible for us. We thank Mr. Deepan also for his presence. We have to thank our immediate past national president, Dr. J. Jayalal, a lot, because he is one person who always for the knowledge dissemination in any possible way to the family physicians. His passion towards that family physician ship is very great, and is one of the backbone that CGP is raising up nowadays. So thank you all once again for a very wonderful sessions, and we thank all the participants who are very well participated, carefully listened to the lectures and also asked meaningful questions. That we thank you all for the concentration you put today in this sessions. Once again, we thank you all and see you soon in some other forum in a very effective way. Thank you all. So we are towards the closing of this program. Thank you.
Thank you. Let us end this thing. Thanks. Thanks, everybody. There are around 44 people were on Zoom, and around 500 plus were on YouTube. So it was really a good success. So congratulations to the team IMA CGP as well as the team Genescope. Let us end the seminar here.
So Dr. Bole, just one quick one. I just wanted to say, we had created this vote of thanks for everybody. Can we see the slide?
Yeah, definitely.
Yeah, because I really appreciate everybody's contribution and support and giving us this. So it is a big thank you from Genescope.ai as well to everybody, all the dignitaries and all the participants. Thank you so much.
Thank you, sir. Thank you all. Thank you.
He will be automatically known.
Keep coming. Thank you. Good one.
Yes, sir.